One other thing I'd like to do is just probably introduce my team that's on the call. I think Incit Suhadi, who's our head of cement, is either about to jump on a call or is already on the call, because I'm aware he's on another call at the moment. And our head of concrete products, who actually, brought together these 5 esteemed speakers, Alex Wong. He's either also on the other call or probably on this call at present already. So these 2 gentlemen are very much on the coalface of the subject matter today. But probably what I want to touch on a bit is the overarching topic of this talk, or this conference, which is empowering industry and transforming society through engineering, technology, and management. I came across a saying where an engineer is really one of the few people who get excited about things that no one else really cares about. So I remember in university, we used to have a lot of funny sayings about engineers, and this is one that sticks in my head because I think engineers are people that work extremely hard in the background, all the way down to the atomic level, which is where I spent a bulk of my final year doing my thesis on an aluminium, magnesium, scandium alloy, and inside a TEM. I never knew a microscope could be that big, and the amount of hours I could spend staring at atoms and grain structures moving here and there and everywhere. So I think what I would like to conclude on that point is that every single one that's on this call who is an engineer has a very pivotal role to play in our day-to-day lives. And I think I'd just like to make sure everyone appreciates what they do, aware of the impact that they have. And I think I've been privileged enough to have experienced many outcomes from amazing engineers across my time working in all the way from Sydney back to KL, and then now in Kuching with CMS. There's still a long way to go. I mean, concrete is really the fundamental building block in a lot of what we see outside in the cityscape or the infrastructure that we ride on or walk on. We started from very humble concrete to, I think, the trigger point where concrete really took the forefront of the buildings is when reinforced concrete came about. And today we're talking about self-healing concrete. So I'm not sure where, this talk on concrete or the evolution of concrete will end up, but I'm sure today's sessions will be one of the many stepping stones towards this particular material, fully realizing its potential. Maybe another thing I'd like to say is just to thank the 5 invitees that we've put in place to anchor the various sessions that we have today. I'd just like to say a big thank you to Dr. Zach Lim. I read up on your profile and I saw all the projects you did. I cannot tell you how many times I've been to the IKEA car park and actually made a mental note of how flat it was. I was always wondering how it was done or who did it. And when I was reading through your profile, I'm like, this is the man. So, I think thank you for your good work, and I look forward to listening to what you have to say. Mr. Yo as well on marine concrete. Thank you for, contributing today. In advance, Mr. Eric Sung, Mr. on decorative concrete. This is my fellow alumni from New South. And another Mr. Alex Yap on admixture evolution. Welcome and thank you. And last but not least, Incit Rosli Idris, who I see has spent a lot of time in Japan, where our standards of concrete, they are absolutely amazing. When I visit the place and I look at their off form and their various ways of exposing concrete as a form of art, I think it's something that we can all learn from. So I think all I want to say now to conclude is that I hope everyone is able to grab a few nuggets of knowledge and wisdom out of this esteemed panel. Ask away And if you have any questions to do with, say, CMS for that matter, I think my email address is always readily available, or my phone number is through Jacqueline, and I think the rest of my team will extend that same token of appreciation and also openness in regards to any forms of questions or collaborations that you may have in mind going forward. So on that note, thank you very much again for having us, CMS, as part of your conference. And I dare say we look forward to many more years of contribution towards the betterment of our various industries. Over to you, Doc. Thank you.
Okay, thank you very much, Mr. Sean Mock, for a very interesting and very enlightening welcoming speech. Yes, I agree with you that engineers always work in the background and then we never blow our own trumpet. So it's through events like this that we can start blowing our trumpets and then highlight whatever advancement that we have made for the mankind, right? So for the first session of this special track sponsored by CMS Group, we have Dr. Zack Lim from Zack Lim Flat Floor Specialist Sendirian Berhad, whom is Managing Director. And he's giving us the talk on the topic of best practices for concrete pavement using fixed form. Before we start, let me read out Dr. Zack Lim's profile. So Zack Lim earned his bachelor degree as engineer from the City University of London in year 1981, when I was in my second, probably primary school, and obtained his Doctor of Philosophy, PhD in Civil Engineering in year 2018. And in year 2000, Zack Lim Flat Floor Specialist was incorporated to venture into construction of super flat floors, with which Asia lacks the expertise, and later having achieved building many floors off. Over 39 years in construction, he has amassed great experience in construction and gained recognition after having constructed many signature industrial flooring jobs of world-class standards in Asia. He has been actively involved in sharing his experience and knowledge as speaker in many seminars throughout Asia and advising young engineers, contractors, and extolling the virtues of best practices on construction of concrete floors. He was the past president of American Concrete Institute, ACI Malaysia chapter, and set up Academy of Concrete Technology mainly to organize practical concrete and construction seminars, field technician certification with objective to foster regional integration for the concrete and construction fraternity. Lastly, in year 2018, he was honored the fellowship award by the Construction Industry Development Board of Malaysia. He from he is from IIC University of Technology, Cambodia. Okay, so without further ado, now I would like to invite Dr. Zack Lim to present on his topic, best practices for concrete pavement using fixed form. So the floor is all yours, Dr. Zack Lim.
Okay, thank you very much, Professor Ng, for the brief introduction and to talk so highly about me. Thank you very much. So I think time is running out. Without further ado, I would like to start off with my presentation. All right. So as you know very well, Malaysia is heading towards concrete roads. All right. And I think it is a good chance for me to talk a little bit about concrete pavement. All right. So firstly, I would like to thank UNIMAS, all right, for organizing this ENCON 2020. And secondly is another big thank you to CMS for inviting us, to share our knowledge. Okay, without further ado, I'll start off my slide. Okay. Basically, about concrete pavement, there's two ways of doing it. One is, of course, is a cheaper method. where you use a fixed form, all right? That means you need a site form work. As you can see in this picture, right? You need a site form work to contain the concrete, and then you use a simple a kind of vibrating truss script, all right? And like I said, any contractor can build a concrete pavement, isn't it? I mean, as long you get the concrete, you place it, you vibrate it, then you just finish it off and done. But is it that simple? Trust me, I always say that it's not that simple, because anybody can do a concrete pavement, but to do it, all right, with no distresses like cracks and other defects, which I'll talk on later. This is the most challenging part. Okay. Like I say, this is the other method, which is really using a big slip-form machine. This is more mechanical, where you want to do very big projects, and these concrete roads for highways, all that. And just now for the fixed form, you use it more for the rural areas and smaller projects, all right? Where the investment is less than probably 50,000 ringgit. And if you want to use a slip-form machine, it will cost you, easily 2 to 3 million. So I'll show you a little video, what is a slip-form machine all about. Okay, actually, this is a video taken while we are building the KLIA 2 pavement for the aprons. All right. So basically, as you can see, with this system, you don't need any site form works, and the speed of work can be probably like 10 times faster than the conventional. Okay. So, like I just mentioned just now, anybody can do a concrete road. But to do a concrete road without all these distresses like cracks, spalling or breaking up, and that concrete slab always curl up at the edges, and you see all these, sorry. All right. Water puddling, okay, and then the joints especially. Joints are very, very important. How to do a joint that is perfect, right? And of course, it can be due to settlement or the cracks up. And lastly is undulating the surface. So that will impact your rideability and all that. So these are the main challenges of how to do a floor, without all these distresses. So I'm going to talk about why, best practices is very important, isn't it? So it is a process where you must do it right the first time. With concrete, don't do any rework if you can. That's why it's very costly and, waste of time, and everybody's problem can be avoided. So second thing is that, it is a guide for you to follow after a lot of trial and error. So if you follow, you wouldn't have so much problem. And third thing is a proven framework to do things faster and better, right? With no reworks and repair. And another way is to have a standard to follow, right? To ensure that you achieve your qualities. And lastly is probably to avoid all the costly repair. As you know, when you do a floor that is not right, the repair can cost you 2 to 3 times more. Okay, so I'll talk a little bit on the various types of good construction practices. The first one is the concrete mix design. As you know, it's important. Even the type of cement is important, especially today we are using a lot of cementitious supplementary material, right? Then the cement content also plays a part, right? If you don't have enough cement in the concrete, you know very well, you have a lot of spalling and inferior concrete and all that. Especially as you know, cement is the most expensive component. So you need to optimize your cement content. Then the water cement ratio, which is also very important. As you know that, when the water concrete is too wet, you get a lot of cracks. That's where the main causes of crack is, right? Then the concrete strength, right? For concrete road, I reckon that it's good to have a minimum of grade 40 MPa. Then your slump, right? That's give you your consistency, concrete temperature. Especially is important because you're working on the external, right? So concrete temperature is something that you have to really monitor. Okay? Generally, you shouldn't have anything more than 36 degrees centigrade. When we are doing the airport, all right, the temperature was pegged at 30 degrees C. Anything more than 30 degrees C, it will promote thermal cracks, okay? And last thing is concrete bleeding, which is important for those who doesn't know what is concrete bleeding. It is basically after when you place the concrete, half an hour to an hour, you see a lot of water appear on the surface, a thin film of water on the surface. That would actually help. You want a bit of bleeding if you are doing external work. That will prevent a plastic shrinkage crack, which I'll explain later. So, and of course, you don't want to add water, okay? Because this water would actually, you know very well, would weaken your concrete. And then you have to make sure that the temperature is right. And then your slump, you have to do a slump test on every load of concrete that's delivered to make sure that it's consistent. Right. Okay, just be a minute. I need to pull up this. Okay, then it comes to the formwork, you know. You see, doing a fixed form, all right, the most important is the side formwork. It's because this is when you want to control your level, all right, this is the method that you can actually control. Because you know why? First thing, your formwork has got a bit different. As you can see, this is a standard formwork, but we add in a little bit of a flat plate here, all right, where we can adjust the height, all right. So once we determine what is the level, that's where we'll nail it, and this will determine our finishing level. And then after that, we have the machine called a truss grid that will rest on top of this. And when this machine run on top of this, it will determine our level and our flatness and all that, okay? That's why formwork, you have to pay a lot of attention and make sure they are well aligned and straight and all that, okay? So that's why it's so important. Okay, placing of concrete now, all right? So make sure that, the subbase is well compacted, all right? It's clean, free of water, all right? Because when you have water there, when you pour your concrete, it would increase the water C. And then when you discharge it, make sure that you don't pile up too much and it's well distributed. And the most important thing is to avoid cold joint. As know very well, let's say if you are pouring your concrete, all right, and then there's interruption of supply. Say after 2 hours or more, if the fresh concrete comes in, all right, what you will get is the concrete, the new and the old wouldn't intermix. As a result, you get a cold joint here. So because of this cold joint, it would cause a crack if it's too severe. Okay, then we come to compaction of concrete, all right? So as you know, why we need to consolidate the concrete is because basically we want to remove all the entrapped air and all this air voids inside the concrete would actually reduce your concrete strength, and they are more permeable to water and all that. So when you vibrate a concrete, you're actually making the concrete denser and all that. So you must know also how to vibrate. But today, we don't have the time to elaborate. And so the other thing is you don't over vibrate, all right? If you over vibrate, you will cause segregation to your concrete. That means the heavier particles will be at the bottom, and then the mortar will be on the top, right? Very important is to make sure that whoever handles the vibrator, they are well trained, all right? Vibrating concrete is not that simple. You must know, how long to vibrate, when to stop, things like that, distancing and all that, okay? So after when the concrete have initial set, I mean, they have start to harden, you should stop your vibration. If you continue, it would promote a lot of hairline cracks and all that, okay? And then the ages, I'll explain later, right? Why the ages are very, very important. You have to vibrate them very, very well. Standby vibrators, all right? When we do the airport, we need to have like 5 machines on standby. You'll be surprised sometimes, a lot of machines will break down. This is what I mean by, you see, if you look at this picture, all right, especially at the edges of concrete slab, why you always see a lot of spalling, right, as shown in this picture, right? There's actually a few reasons, all right? One of the reason is caused by vibration, all right, as I can show you from this picture. You see, because sometimes when they don't do a good site formwork, the workers tend to vibrate very far away from the edge of the formwork. As a result, this area is not well vibrated. If they vibrate too close, you're worried that the formwork will fail and the formwork might bulge and all that. So as a result, they stay away. So if the concrete around here is not well vibrated, this is what happened actually, all right? There's one cause. And the second cause you can see from this picture is that, the excess, all right? When you do a concrete, when you stop, all this excess, you need to remove them. So what happens if you don't remove this, if this buildup is there, right? When you cast your adjacent panel, what happens? This area is very thin, all right? It could be, let's say your slab is 150 mm thick, all right? This area could be only 50 or even 30 mm thick. As a result, when the vehicles, heavy truck run over it, it will start to break like this as well. So that's the reason why all these edges are very, very important, all right? This is a sign. Sometimes when you see a crack like this, all right, it's a reflection of what's below, all right? All this because the excess wasn't removed. So that's the reason why the edges are, make sure that, you finish it off at a 90 degrees edge, all right? And another thing can be due to curling. As you know, all concrete floors will curl, especially if you're doing concrete pavement. You'd be careful because wherever you stop, the slab might tend to curl up. When they curl, it could actually causes breakage like this as well. Because when the concrete curls up, when the heavy vehicles run over, it would start to break the concrete. So these are the things you got to be careful, all right? So today we don't have the time to talk about how to prevent all this, Okay, so the striking off or the screening of the surface, as you can see, that's why your formwork on both sides is very important, as this machine is going to ride on top of your formwork. So if you do it right, okay, I'll show you a simple video how it works. Okay, basically that's how, you have to check your level, and once you set your formwork right, that is your finishing level. So whether you want to tilt it, to slope it so that there's no ponding water, and this is how. That's why I've mentioned earlier why the formwork is so important, right? Then, of course, you have other screening machines, like this one is just a pipe roller, you know, where you can help you to strike off your concrete. And you can have another one called like a double beam, you know, and there are various, even you have laser machines and all that. Okay. So one of the reason how you actually make the surface very flat is using what we call a channel float. It's like a flat aluminum hollow section, right? And with this, you actually help you to flatten the surface, right? So you would remove all your bumps and fill up the low spots when the concrete is still wet. Okay. Just to show you, sorry, just a quick video of how this thing works. Okay, so a very simple tool. That's how you get your surface flattened, right? Then we come to the surface texturing, right? So there's a few ways of doing the texturing, but the common one is just using a normal broom finish. So when you brush it, you make sure that they are well aligned and straight, you know. Then the depth is important because of the traction. You know, you don't want the road to be too slippery. So make sure that your broom line, the depth is about 0.7 to 1.5 mm. If it's too rough, then it'll be too noisy as well. Okay. And make sure that you clean your room every time so that, you know, the mortar wouldn't build and dry and stick onto the broom. So in US today, rather than a broom, they actually, even in China, they cut the groove line using machines to cut groove line, and they actually do it longitudinally. So this would avoid a lot of sound, all right, compared to the groove line, all right, where that is more on the transverse direction. And this one is longitudinal, has to drive, you know, you see the direction of groove. So that would reduce a lot of noise. Okay, coming to curing of concrete is very important, all right. This is not a right way to cure concrete. As you can see, they use gunny sack. There's nothing wrong, but you know you have to cover this, you know, completely and not leaving a lot of space in between for the moisture to escape. As you know, why concrete curing is very important. Basically, what you want to do is to trap all the moisture inside the concrete for the cement particles to continue the hydration process, right? If you don't cure it well, you know that your concrete strength can drop as much as 30%. So for outdoor, we don't recommend to use this kind of method because of the strong wind, and then it's hard to get water and all that. So the best method is to use a curing compound. All right, you spray a layer of curing compound on the surface, right? And you know, might know that basically uh, there's two types of curing compound. One is a 60% efficiency, and this is a 90% efficiency. What it means is that if you use a 90% efficiency, after spraying, all the moisture will be trapped within the concrete for the cement hydration process, right? And you can have it in white or silver to reflect lights and all that, okay? So curing is very, very important, all right? If you do it on the external, on a hot day, all right, let's say around 2, 3 o'clock when you finish, you have after brooming, if you don't spray your concrete with a curing compound, you know, this is what happened actually, sorry. You know, this is what happened in this picture here. You see a lot of surface crack, all right? And this is what we call a plastic shrinkage crack, right? And all these cracks happen just before the concrete, you know, gets very, very hard. So that's the reason why, you know, curing is very, very important when you are doing external work. If not, you'll get a lot of cracks, and it's very, very difficult to repair it. Okay, then we comes to contraction joint. Basically, contraction joints is a soak-up process where you actually control the cracks. As you know very well, when you pour a concrete, all right, that is narrow and very long, you will get a lot of cracks. We call a transverse crack in this direction, all right? So in order to avoid all the random cracks, the only way is to do a process using a diamond cutter, and that's where we induce all the crack to control all the crack line. As you can see, it's okay. I should have a picture of the, all right, this is important. As you can see that actually this is a slab from the airport, which is 400 mm thick, okay? So the first question is when to cut, right? And those days when I was a contractor, all right, I will cut as and when I'm free, all right? It could be a week, it could be 2 weeks, but actually it's wrong. You have to cut within 8 to 12 hours if you can. In other words, as long as the concrete is hard enough, when you put the blade, all right, the edges doesn't chip off or ravel. That's where you have to go in with it, all right? So the earlier you go in, the better, all right? Not after 2, 3 days. It's definitely too late, because by then a lot of micro cracks is built up, but you can't see it, right? So the second question is how deep to cut. All right, the rule of thumb is that you cut about 25% of the slab thickness. As you can see, this slab is 400 thick, so we cut about 100 mm. Okay, so about 25% of the slab thickness. All right, if you're using fibers, you probably cut 30%. All right, to induce the crack. Right. Then the third question is how far apart. I mean, after cutting the first line, how far you have to cut the second one. All right. So I think the second slide would explain that. So this is a case study, all right, where we actually pour a 5 meter, or all the airport that we pour is 5 meter wide, and it's good to cut every 5 meter. That means you cut it square, 5 by 5. But the aspect ratio is 1:1.5. That means if this is 5 meter, 1.5 times is 7.5 meter. That's the maximum you can go to be safe, all right? So you follow this principle, you are very safe. That means every 7.5, when you cut, you don't have any cracks in between, okay, isn't it? Because saw cutting also costs money. So you want to, again, optimize it. Like, if you want to be aggressive, you might go 2 times, even every 10 meter, but there's a risk, all right, as you can see here, right? So when we try and cut every, let's say 5 meter, right? Every 13 meter we cut, all right? You might have risk of 1 crack between or even 2 cracks, all right? So when you see this, you know that your contraction joints are too far apart. So these are good practices that you need to know to control a lot of random cracking, all right? Okay. Then the next thing is, like again in the airport, there's no reinforcement in the mass concrete, all right? So there's, except where the joints are. Wherever you want to have a contraction joint, we need to do saw cut. That's where you actually place all the dowel in position, all right? And then you cover it, all right? And you make sure all these are horizontally placed, all right? If these are not straight and not well aligned, all right, it's also bad, because when later when the concrete wants to open up, this would actually lock up and you might have a crack by the side. So these are things that you got to be careful, all right? And the last thing is the hot weather concrete thing. As you know that when you're doing all this concrete pavement, it's always under the hot sun. There's no shade, all right? And first thing, you have to be very careful on your slump loss, right? So if your slump loss, that means the concrete is a bit dry, then it's very difficult to place the concrete, all right? Then it's the setting time is much faster compared to a cooler day, isn't it? So generally, if you use ordinary Portland cement, at probably 3 hours, you will see the initial set. But in even the hot weather, probably even 2 hours, sometimes you see start to set. So you got to be very careful. And this is one of the common enemy, like I mentioned. These are all the plastic shrinkage crack. If you're not careful, you get a lot of cracks on the surface, all right? So when we did the airport, like 80,000 meters square, we have not a single plastic shrinkage crack because of the precautions. and the best practices that we have been following, right? And thermal crack, all right? Thermal crack is something that it will happen immediately in the first probably 1 to 3 days, all right? And all this thermal crack is caused by either the concretes are too hot or direct sunlight under the hot sun. Of course, the other cracks are drying shrinkage crack, which will happen many months down the road as the concrete start to shrink, right? The water start to escape, concrete start to shrink, and then it start to crack. Whereas when you do external concrete pavement, thermal crack is something you got to be very careful, all right? And that's the reason why when we do a lot of factory floors and all that, when we cast the concrete, we always want to do it in the late afternoon, like 3 o'clock we start. So we work during the night and we finish around in the morning. And we find this concrete will have less crack compared to the one that we start early in the morning. And then by 2, 3 o'clock, the hot sun is there. And next day we see cracks start to appear, right? And like I mentioned earlier, it's good to design your concrete with a little bit of bleed water on the surface, all right? So that will prevent all this plastic shrinkage crack from drying up. And carrying out fogging. Fogging actually is a process where you use a water jet and spray, moisture into the air. So when it drop on the surface, that will help the surface to a bit saturated and it wouldn't dry up and crack so easily. And of course, you can even spray a chemical which delay the surface from drying up, such as aliphatic alcohol, colloidal silicas, and all that. Okay, so I think I've come to my conclusion, and just for the interest, I always like to ask in my seminar, why this repair failed, right? You can see that they have actually, this is a joint, all right? This is a joint, and they have repair, and then it cracks back again. What causes this crack? So since you all can't answer, I have to give you the answer from here. So there's two reasons. So this repair is done during hot weather, which is true. Let's say if you start at 12 o'clock in the afternoon, all right, and you put this concrete down, trust me, because of the excessive heat and everything, this concrete would actually already crack, okay? Would start to crack. So it's also, again, good to do any repair in the late afternoon, all right? So during the night, it's much cooler, and by the morning, the concrete would have gained the strength and all that. And another reason it could be open up to the traffic too early. As you know very well, unless you use a fast set concrete, all right, you can open up even 6 hours, all right, to let's say 24 hours. That's called fast setting concrete, all right. If not, you have to wait for at least 4 days before you can open up. But a lot of people doesn't understand. They will just use a normal concrete and then they repair it, and the next day they say, oh, it's hardened, and then they open up for traffic. Of course, you don't see any problem, but a lot of micro cracks starts to build up, and after a month or so, you see you start to break and go back to square one. Okay, I think that's all I've got to share. And thank you very much for Unimas and CMS for inviting me to give this small presentation. Thank you. Pass it back to you again, Professor Ng. Thank you.
Okay, thank you very much. Thank you very much, Dr. Zach Lim, for your presentation on concrete pavement.
Yeah.
That is not very common in Sarawak. So
Yeah.
I think there is a question from Mr. Muhammad Jamil here. Actually, there are two questions. So his first question is, what is causing bleeding in concrete? And then the second question is, in your view, is there any opportunity for concrete road construction growth in Sarawak? Is there any potential for the concrete road construction for Sarawak?
Yes, yes. Okay, the first question on the concrete bleeding. Actually, what causes bleeding in the concrete is because it's lack of fine material. That means not enough cement. Imagine you mix your cement, sand, mortar, all right? You have little bit of cement in there. You see that you bleed a lot. But if you add in more cement, you will find that the bleeding will stop. So when you are a ready-mix supplier, to avoid bleeding, what you got to do, you either add in any fines, can be cement, can be CC powder, can be even fine sand, because you know why? These fine particles, you need water to coat all these particles. As a result, you need to have more water to coat the particles, right? So bleeding actually is caused by lack of fine, one of the reasons. And of course, is excessive water in your mix, okay? Let's say you got a water cement ratio of 0.65 or 0.7, it would definitely have more bleeding. Yeah, okay. And like I say, bleeding is good and bad, all right? Most of the time, you don't want bleeding because too much or excessive bleeding on the concrete surface would actually cause the surface to have efflorescence. That means they are very dusty and powdery, all right? Excessive. But when you're doing external work, you want a little bit of bleeding so that the surface won't dry up too fast and you know, you have a lot of plastic shrinkage crack. And the other thing is that like us, we do floors, we need to sprinkle hardener, right? Those are like cement, sand on the surface. So if you got a bit of a bleeding, I don't have to add in more water on the surface. You know, adding water on the concrete surface is bad, all right? You get a very dusty and weak surface, things like that, okay? Right, so talk about potential of concrete can be pavement or, you know, in or concrete roads in, actually JKL is looking into concrete roads, all right? By right, by now, Malaysia should have at least 10% of concrete roads by now. Unfortunately, I think we don't even have 1%. It's just the North-South Highway in West Malaysia. But after that, you know, we hardly have any. Until lately, we have one small stretch in Kuala Lumpur. So I think the government is looking into concrete roads, all right? That's why your PAM Borneo, all right, supposed to be a big project, and I'm sure for rural roads, they'll be very good, all right? Because concrete road, if you do it right, it will last at least 50 years to 100 years, right? Compared to asphalt. So, and then in Malaysia, we got a lot of cement, right? Those days, concrete road is like double the cost of asphalt. But today, asphalt is getting expensive and we have a lot of cement. I think the price is getting very, very narrow now. Yeah. Yeah. So trust me, you will going to see a lot of concrete roads in Malaysia. Yeah. Because you look at all the neighboring countries, all right, even up to Cambodia, they are all into concrete roads now, except Malaysia. We used to be the leader, the pioneer. After the North-South Highway, we are behind. So we have to fly our Malaysian flags again, all right, to say that we are the champion again on concrete roads. Okay, yeah.
Okay, there's another question from the same person, Mr. Muhammad Jamil. So his question is there any chance we can reduce heat of hydration just by adding silica fume and fly ash without GGBS?
Okay, as you know very well, right, all these silica, not so much on silica fume, all right, especially the BBGS and the fly ash, isn't it? If you're doing mass concrete, all right, that's where it's very good to use because it will reduce the heat. As you know that the heat of hydration is much, much slower compared to OPC, all right, ordinary Portland cement. That's the reason why when you are doing a mass concrete, let's say for basement slab, where anything more than 500 mm thick, right, you got to be careful, all right? If you're using OPC alone, you're bound to have a lot of thermal cracks, all right? And that's the reason why they use at least 30% of fly ash and up to, I heard even 70% of BBGS for basement slabs nowadays, yeah. So why the main advantage is the low heat of hydration using all this, okay? Yeah. But for us, when we do, let's say, external concrete floors, all right, we prefer not to have any of these ashes added into it because why? It delay the setting, all right? There's two disadvantages. One is, for example, I'm a floor specialist, right? When we use OPC, all right, after 3 hours, my workers can go in, to start doing the finishing. But if there's any 30% of, let's say, fly ash in there, it would delay the initial set from 3 hours to even 8 to 10 hours. And my guys will be sitting there and waiting, all right? So we prefer not to have any ashes in there. So there are advantages and there's disadvantage, Likewise, when we're doing a slab for external, we find that with OPC, we'll have less crack. With the fly ash, we'll have more cracks on the floor. Yeah, so there's always pros and cons. Okay, I hope that answers your question.
Okay, the next question is from Mr. Yo, who is also a panelist here. So his question is, what are the benefits of concrete road?
Oh, benefit of concrete roads. Actually, there's so many, right? Like I say, concrete road is something, if you do it right the first time, all right, it will last you a long, long time, all right, at least 50 years or more. Second thing, concrete compared to asphalt, especially in our Malaysia weather, we got a lot of rain. As you know very well, after a rainy spell, you see all the asphalt will start to break up, isn't it? As you know, when the asphalt, because they are quite porous, the water gets in after a rain, they stay in there, and later they need to escape. When they escape, they have to escape in the form of vapor. All right, that's where the heat is, and then it starts to break up the bitumen, and that's where you get a lot of potholes and all that. But with concrete roads, you don't have an issue, isn't it? Whether the rain or shine, it's definitely more durable. And even for concrete roads, all right, vehicles like big trucks and all that, they find that the fuel is less where they consume. They can save as much as 20% of fuel, right? Compared to flexible because of the load, all right? Because on the concrete road, the loads are more distributed compared to asphalt where it's more focused. So it will affect the reliability and things like that. Yeah. And let me see, there's actually a lot of other, like I say, the repair, all right? For asphalt, every probably 10 years maximum, all right, you have to resurface again, right? Yeah. And I just mentioned earlier, but make sure you do it right the first time, right? If you don't do it right the first time with your concrete road, the repair will be endless. Yeah. Yeah. Okay.
Okay, I see there is no further question from the attendees. So I have another question to ask you, Dr. Zach Lim. What is the attention that we have to pay when we prepare the subgrade for concrete pavement as compared to the flexible pavement?
Okay. You see, basically, you must see the preparation of sub-basement is very important. That's not my expertise, but when we are doing the airport, all right, they always have to carry out the CBR, Californian bearing ratio test, all right? So they need to have like at least 90%. And even that, because it's an airport, they don't even trust the test. After that, what they do is that they do a proof rolling test. So they had a big truck, all right, where they load it up to about, I think, 2,000 tons, and they ride on the prepared sub base. And you cannot cheat with that, isn't it? Because it's so heavy, if you see any rutting, I mean, any sinking of the ground, then you know that that area is bad. So that is the way you call it the proof rolling test, yeah. So of course, the sub base is of utmost importance, yeah, because we do a lot of concrete floors, even basic concrete floors we know, right? Sometimes contractors don't compact the base well. You see a lot of settlement crack, we call it, can happen, yeah. So the test.
Is there any difference between flexible pavement and concrete pavement in terms of all these subgrade and sub-base preparation?
Actually, I think for concrete, you don't have to be as stringent as asphalt. I think asphalt, as you know, is more of a point load, isn't it? Because asphalt, unlike concrete, where it's more distributed. You see, I don't know whether I should talk about this. For example, our KLIA2, all right. As you can see, after when they open up, all right, the apron is the place where the aeroplane parks. When in those days, without the bridge, you have to walk up and down. I mean, the plane as the plane land, that's actually the apron, right? And initially it was supposed to be concrete, but because during when they're doing the link concrete, which is also about 300 mm thick, they realized there's a lot of settlement, as much as 50 mm. So they changed it to asphalt, thinking that if the floor sink, they just top up. All right. If it sink, they top up again, which is true, that's what they did. And I think cost them a lot of billions. I don't know how much is the cost, but every time I go to KLI A2, I can see them topping up. Original was a special mix, all right, where they have a mortar on the surface, and the color is very light gray. And today, when I go back, you see all black already. So they're using normal asphalt. They can't afford to use the special asphalt anymore. And I believe that if they use concrete, maybe it won't be as bad. Yeah. And at that time, on the asphalt, you can see that, you're not on a plane, you're like on a ship. You can feel that you're like on the ship, when they first open up. Yeah. So I think that's the big difference, yeah, between asphalt and concrete.
Yeah. Okay. I think without any further question, probably we like to thank Dr. Zach Lim for preparing a very interesting presentation to us on concrete pavement using a permanent form, using this innovative way of construction using the fixed form. Okay, and also thank you very much to Dr. Zach Lim for answering all our queries and questions on concrete pavement and also as well as concrete technology. Yeah. Okay, thank you very much again, Dr.
Thank
Zach
you,
Lim.
Professor Ng. All right, thank you very much, Professor Ng. Thank you, everybody.
Thank
Have a
you.
good day. All right.
Okay, thank you.
All right.
And
Doctor. Yeah.
okay, now is the time for us to open up to all the participants for a forum of discussion. Probably if you have not asked your question about Dr. Zach Lim's presentation, you may also ask now. Okay, and I think Dr. Zach Lim just now enlightened us on how all the cracks happens. Probably Dr. Zach Lim, you can kickstart the discussion session by highlighting us how the cracks happen in the concrete pavement. Yeah.
Okay. There's so many reasons of cracks. Actually, I did my PhD on floor cracks, actually. So, there's like more than 10 reasons. So I don't know whether we have the time to talk about this today or not. It's a one whole day seminar on cracks alone. All right. Basically, the main causes of crack, like I said, is still the water, all right, excessive water. There's a reason why when we do a concrete floor, we want to have minimum water. But then if there's not enough water, you find it's very difficult to work, isn't it? You need the extra water to help you to have a good workability, all right? And besides that, of course, like you said, the sub-base preparation is important. And then your concrete grade is also very important. The mix design is also very important, all right? If you use a higher grade concrete, you probably have less crack, all right, compared to a lower grade concrete. And then the reinforcement, all right, the positioning of reinforcement is also very important, the concrete cover and all that. And I mentioned just now the panel size, all right? The aspect ratio of the width against the length is 1:1.5. That is a very good rule of thumb to follow, all right? So that's why when you place your concrete slab, make sure that they are as square as possible. Let me say you want to place a 30 by 30 meter, or you go by 30 by 45. Don't place a 30 meter by 100 meter slab. You have a lot of cracks because, the stress are not equally distributed within the panel. All right. And then even the aggregate size is very important, all right? Aggregate size. So we always want to have optimum size aggregate. So in the airport, because the concrete is 400 mm thick, we use 40 mm aggregates, all right? For the first time, we use 40 mm, all right? And I have done floors before those days where we only use cement sand, all right? And we find that there's a lot of cracks on the floor, okay? So that also, of course, the temperature of the concrete is important, all right? And if you can, you cast your concrete, all right, away from the sunlight, all right? So we have done a lot of floors in the internal, all right, where one side is exposed to the sunlight. It could be a window, a pane, where the sunlight can shine through, and then you see around the area, you get cracks, you see. So like I said, there's so many causes of a crack. Yeah, that's all I can think of. Yeah. And then the design, actually, to be frank, actually cracks partly sometimes engineers or the designer, is also plays a part, right? Because from the designing, it can also causes of a crack. Why? Because they design the concrete slab in such a way that the stress cannot be released. All right. For example, near the beams, near the columns, these are places where you tend to have a lot of cracks propagated from there as well. Okay. Yeah. Okay. So.
Sorry, Chairman. Sean here. I just
Okay.
yeah, I'm not sure everyone saw the note I dropped, but I need to jump on another meeting at 12 p.m. But thank you very much, Prof, for hosting this. And Dr.
Okay.
Zach was enlightening and very simple to follow. Brought me back to my university days.
Okay. Thank you. Yeah.
Okay. Thank you very much, Sean.
Right.
Thank you.
Yeah.
Thank you very much for your presence here today.
Thank you so much.
We are very honored to have you here today to give us the welcoming speech. Thank you.
No. Pleasure is mine, and thank you. Job well done.
Okay.
Okay. Bye-bye. Thank you.
All right.
Okay.
Bye.
See you. Yeah.
Yeah.
And then to all the participants, you can access your mic now. So since our host here has already upgraded everybody to be able to speak, so you can now switch on your mic and start the discussion with us. We want the discussion to be two-way, right? Not only the panelists talking and then the rest of the attendees just listen. No? We want to hear from you also. If you have any problem on site that you have experienced, probably you can share with us. And probably some of the panelists here may have the experience of the solution. Yeah.
Hi,
So,
Dr. Zach. Hi, Dr. Zach. Want to ask about the recommended cement content and water content for normal concrete pavement. Can you give your opinion on that?
Okay, on the cement content, right? Based on my experience, I always say is that whatever you do, the minimum the cement content need to be at least 3 to 5, all right, and not more than 400 for concrete slabs only, right? The reason is, you know very well that anything less than 3 to 5, your okay, let me start off with this again. Is that, you see, those days when I started in construction, all right, before all this fly ash and slags have been used, all right, everything is OPC. So when you hack a concrete, all right, even grade 20 or 25 is common. 30 was unheard of during my time, all right, in the way early 80s and all that. So when you hack a grade 30 concrete, you'll find it's very, very difficult to hack, right? Today, you hack a grade 30 concrete is so easy. And I don't know why it's very powdery and, as though there's not much cement in there. Why? Because of all these ashes. It can be fly ash or slag, you see. Even though you can achieve your compressive strength, but the binder is insufficient, if you ask my opinion. So if you do a concrete road, let's say, with a cement content of maybe 280 or 250, all right, you will get your compressive strength pass, but you find that it is insufficient cement to hold your sand and aggregates together. So the concrete will easily break and spoil, all right? So there's a reason why it's always good to have minimum 3 to 5 for pavement. and you vibrate it well, the concrete will be almost impermeable to water, right? So in concrete, you don't want the water to get inside the concrete because later when they want to escape, they have to escape as a steam or a vapor. So that's where the concrete will have a lot of stress and problems, right? Then the other thing is the water content, all right? I would say it should be around 180, 185, of course, depends on your cement content and all that. But anything more than that, we find that, you know, you will have more cracks and all that, yeah. So this is my recommendation. And so, Mr. Yo, you are expert in the concrete, all right? I'm
Yes.
more of a concrete man, so it's good. What's your version on this then? Yeah.
My version is almost, I tested what Dr. Z recommend in one of my project. Actually, we fixed the water C is less than 0.4 and the maximum cement content should not be more than 400. And we found out actually we have a very good concrete, less bleeding, no excessive bleeding, and the surface is free from powdery. That is what we found out.
Okay, I forgot to say why your cement should not exceed 400 kilo per meter cube if you can. Reason is it will promote curling. Curling is, I don't have time to explain the slide today. The slab actually would actually curl up, you know, even the corner or the edge, probably about 300 mm from the end, the slab would actually curl up. And curling is very bad for floors, especially today's warehouse floor. If the floor curl up and the forklift run across, it will actually break and crack. So excessive cement will promote curling as well. Yeah.
Thank you, Doctor.
Yeah.
Okay, any more topics of discussion from the participants, from the other attendees?
Malaysians are always too shy to ask. I was in India, we have to stop them, you know, hey, it's enough, no more question, no more question, you know.
It's the best time to have free consultation, you know.
Yeah, whatever I
if you
know,
ask.
I'm willing to share, not to worry.
This is the best time you get
If you don't
free
ask, you don't
consultation.
learn. Yeah, don't ask, you don't
Yes.
learn, right?
Yeah. So you may share with us your experience on site. What are the problems caused? No? When you see spalling
yeah.
of concrete, you want to know what is happening to your concrete. No?
Yeah, okay. But it's a bit far for you all to come over.
Yeah.
Yeah. All right.
Okay. Anyone having an issue in your concrete?
I believe down here we have a lot of engineers, maybe architects. I want to ask something. Is it a practice for Sarawakian, our ready mix, to check the concrete temperature? Because I saw from Dr. Zaid, normally we need to measure the concrete temperature when it reaches the site. Is it a practice in Sarawak?
Okay. Anyone from the attendees here who is a practicing engineer? Can you enlighten us on this issue here?
Don't be shy.
Sorry, you need to unmute yourself, yeah? Don't forget to unmute yourself before you speak.
Yeah, you see a microphone button at the bottom of the app, so you can click on it and you can speak. So since there's no response from the attendees here, probably for checking the temperature, it depends on whether it's specified in the specification or not. Right?
Okay.
A lot of time in JKR spec, I don't think there's any need to check the temperature. Is it a trend now in West Malaysia that you always have to check the temperature?
NJKL say you shouldn't exceed 36 degrees C, 36, yeah.
So do you put that in your spec?
Even over here, we are not so particular, to be honest with you. Yeah, I think nobody really check, unless we are doing mass concrete. That's where I think, for example, the 118, they are building now in,
Okay.
yeah. So they are very particular about the temperature. I think most of it falls around 20 over degrees C. And they even use nitrogen, to cool down the temperature if it exceeded. Yeah.
Correct.
Oh, that is quite a big extent to control
Yeah.
temperature.
Yes, yes, yeah. Every truck, yeah, they have to check it. Yeah.
From
that's why.
Yeah,
yes,
because of the friction, by the time they pump up, the temperature would shoot up, you see. So
Yeah. Because of the friction. Huh?
friction, yes, yes.
from our aspect, like precaster or special project, most of the concrete we need to measure the temperature. And like Dr. Z mentioned earlier, if we don't measure the temperature, sometimes our concrete's very fast. What is called setting. Setting is means from plastic to solid. The process happen very fast. Suppose it's around 4 hours. Sometimes we even get less than 2 hours. The concrete actually become hardened. So the workers cannot do the concreting job. So this is very important. So it is specified by the court, our Malaysia court, and also JKR court. Your temperature should not be more than 36. So if
Yeah.
even it's not mentioned, if your concrete exceed 36, the site supervisor or the engineer can actually reject the concrete.
Yeah, okay. Yeah, another important thing, as you forgot, is the delay entry guide formation. We call it DEF. Yeah. So maybe you want to explain on that.
Doctor, that one I explain later in my slide.
Oh, in your slide, okay. You want to keep it
Yeah.
for your slide.
I want to keep it later. Okay.
Yeah, like delay entry guide formation. Okay.
Okay. So
Yeah.
that is
A
temperature
little bit
control.
on that, because we call it in short is DEF. It doesn't happen immediately, but it always will start to have the reaction many years down the road. Can be 10 years or more in the presence of moisture. Yeah, maybe you will explain on that later. Yeah, it'll be good.
I think that one, Mr. Jamil will be very interested in that topic just now because he asked you about the temperature control, the heat of
Yeah,
radiation.
yeah. Okay.
Okay, Mr. Jamil, do you have any further questions?
Yeah, I got one question.
Okay.
Okay, this one regarding the which one is better lah. Okay, usually we will use reinforced steel bar to design a pavement, and then also currently they have a new technology whereby they're putting a fiber inside. I think maybe in your opinion, which one is good lah? I think maybe in terms of strength, maybe to reduce a crack, something like this.
Okay, Jamil. So this is actually based on the cost, you see. Of course, fibers is not new. Actually, a lot of people think fiber is new. I started to do my first fiber floor 20 over years ago, all right? And at the time, it's unheard of almost. So for highways, there's a few types of road. Basically, there's 4 types, but no time to explain them. But most of it, like for kampong roads and all that, you don't need any reinforcement in there, all right? The most is at your contraction joint. You might put in some double bar, all right? So for reinforcement, only for highways, all right, where there's heavy loadings, where you need the reinforcement. So there's 2 ways. You either use the conventional mesh or rebars, or alternative is to use fibers. All right. Of course, fibers, you have got the synthetic fibers, you have got the steel fibers and all that. It's only thing the dosage, all right, how much to put in, all right. So I'm a fan of fibers, to be frank with you, because when I do let's say a suspended floor slab, only on the ground, right, not elevated. Elevated, you can do it as well, but it's a different design altogether. So if you use fibers, you see, you save a lot of time. all right? You don't have people to lay all the reinforcement, you know, cut the mesh, overlap, tie them and all that. So fibers, when the truck arrives at the site, you just throw it in, mix for 5 minutes and you drive in, discharge, and then you drive out. So it's fast, it's quick, all right? And if it's more than 2 layers of reinforcement, let's say a mesh, normally fibers are cheaper and better, and better crack control. As you know, reinforcement, if you the mesh, if you don't place the cover well, all right, it's a waste, all right. The crack control is very bad compared to fibers, where it's 3-dimensional, it's all over the concrete. So for crack control, fibers are always better, all right, you know. Yeah. End of the day, you have to work out the cost. And there's a lot of indirect saving if you're using fibers, right? First thing, you don't have to use the pump mix. You don't have to have people to lay all the reinforcement. You don't have to have all the spacers, you know, and there's so many things, right? So end of the day, if you look into all these little savings, you know, the cost can be even big savings. Sometimes when we do concrete floors, you know, we can save, you know, even depends on the floor, we can save, you know, tens of thousands, yeah, if you're using fibers, and they are much better. Yeah. Okay.
Thank you,
I
Doctor.
hope that answer your question. Yeah. But end of the day, if you ask me, of course, people still have got the confidence with seeing the steel bars there. All right, this is what the perception is. Yeah. For example, we did the airport hangers, right? Originally, it was 2 layer of reinforcement, and then we changed it all to only 20 kilos of steel fibers. And the load, I think, for the plane is like what, 300 over tons. You know, we don't have an issue after that. Yeah. Okay.
I think
So
the
all the
application,
yeah.
the application of fiber is still uh, very rare, as I can see in Malaysia.
Yeah, too
Because
conservative. Yeah.
yeah, I think because of our labor cost as well. Our labor is very cheap, so they will
Right.
rather
Right.
do the tying of reinforcement, but and not using the fiber. That I think the perception as well, that the thing fiber is very expensive, and
It can be cheaper end of the day. It depends, like I
yeah,
said, on the reinforcement. Yeah. You see,
and
because of the
there's
dosage of the loading, you know, yeah. So yeah.
and then the design. Another aspect is the design engineers. They haven't
Yeah.
done any design on.
Yeah, the coats, yeah, probably is the coats,
Yeah.
yeah, as well, yeah, on the fibers, yeah.
So because of there's lack of code of practice, but there's already code of practice for Eurocode 2 in the application of fibers. It's just that our engineers they haven't seen and they haven't touched on the design of this type of
Yeah, Professor, I
materials.
always tell
Yeah.
some engineers, I say, what can go wrong on the floor slab, on the sitting on the ground? You know, it won't
Yeah.
collapse. The worst can happen is cracks and all that. Even with reinforcement, with steel reinforcement, you still get a lot of cracks. The same, or it could be even worse.
Yeah.
What can go wrong? It won't collapse. It's not like elevator. I think in Europe they even
Yeah.
use fibers for elevator slab. They say up to 10 story, you know, but it's very high dosage. For over here, let's say we use 20 kilo of steel fibers, but for elevator slab they might use up to 80 kilo of fibers. All right, and they have got very minimum rebars, you know. Yeah. So it's
Yeah,
just that, yeah.
that's
Somebody
a
have
very
to,
good. Actually, using fiber is a very good way to reduce the congestion of reinforcement, especially at the
right.
joints. Imagine
Yeah.
if you have a slab with a lot of steel bars going into the joints, then with the columns and the beam reinforcements, you can
Yeah.
imagine it's a nightmare for the concreting practice.
Right. Even with fibers, even our contraction joints, normally we can go further, you know. Yeah. Our slabs, you can have bigger slabs and all that with less crack. Yeah. So I found there's a lot of advantages using fibers.
Okay, any other opinions from the attendees here?
Dr. Lim, I have a question actually. It's regarding the contraction joints as well. Does the width play a part in affecting the, we'll say, the performance of the contraction joint by any chance?
Yes. Actually, the contraction joint, it all depends. See, you must understand, right? Basically, contraction joint is there to cater when the concrete start to shrink, isn't it? All right. So when the concrete start to shrink, that's where it will pull the concrete apart, and that's where the crack would start to appear. All right. So the distancing is also important. All right. So all these will have to also depends on even the thickness of the slab and all that. You see, of course, if the slabs are thicker, then you can have a contraction joint further than thinner slabs and things like that. You think, yeah. So you see, to be safe, all right. Let's say, for example, we're doing a normal floor slab, right? If I'm using a conventional BRC mesh, I might even go maybe every 6 meter or maybe 8 meter. I need to have a contraction joint. But if I'm using fibers, I might bravely have a contraction joint every 10 meter, for example. All right, yeah. And okay, the only disadvantage we're using, for example, back to fibers again, when the concrete start to shrink, all right, because your panel size is, or your contraction joint is always much further apart, the gap might open up much wider compared to a normal steel fiber, I mean, a normal steel reinforcement floor. It will open up much more, that's all.
Oh, thanks, Dr. Lim.
Okay, of course, the other thing is the movement joint, right? A lot of people call it the expansion joint, right? How far apart you need to have one. You see, contraction joint is something different. Like just now I mentioned, all right, I might pour a slab of, let's say, 100 meter long, for example. Then every, let's say, 5 or 6 meter or 8 meter, I need to have a saw cut, all right, to induce the contraction joint, right? But expansion joint is different. Expansion joint is mainly for floors where you cannot afford to cut. You cannot cut the floor because the reinforcement are continuous, right? Let's say if you're building a warehouse floor of 100 meter, right? It's good to have a movement joint every 30 to 50 meter, all right? Again, subject to the thickness. So you need to have a movement joint where movement joint is supposed to be the slab to be detached. The steel bar cannot go continuous, and you hold the two slab by putting in double bars, as you know, right? So that this slab can contract. So it's a bit different from movement joint, right? Contraction joint. Joints in top, even in our understanding, yeah. Okay. I hope that
I think Dr. Zach Lim, your line is a bit lagging. From the participants, anything that you would like to discuss?
said that
Now, okay, doctor, I can see you now, Dr.
oh, I lost me. Okay.
Yes.
Yeah, just now we couldn't see you and
Okay, so
we couldn't hear you also.
see and hear. Wait, did I talk about the expansion joint? Yeah, about the expansion.
Yes.
Yes, just now.
Talk enough already.
Now should be okay.
Okay now? Yeah.
Okay.
So Eric, did you get
Yep, afternoon. Yeah, my bandwidth is also it's cutting in and out as well. Yes, but I got it.
you got it right? Okay.
Yes. But Doctor, just to add on, right? Like the width of the joint itself, when you do the cutting itself, right? So sometimes you might have like I would say maybe like a 5 mm width worth of the line, or sometimes might be 10 mm wide. Like, will that affect the saw cut in any way, or?
Okay, actually, you're talking about the width of the saw cut, is it? Yeah.
Yes.
Okay, because
Yes.
the blade comes is about 4 mm, all right, 4 to 5 mm. So that's the reason why the width is there. Let's say, for example, if you're very confident, all right, because first thing you must know very well that when the concrete shrink every 6 meters, they can shrink as much as 3 mm. All right. So that's the reason why you don't need to have like a 10 mm for the saw cut joint, isn't it? Because unless it's a movement joint where you expand and contract, then it's different. So for contraction joint, it will only open up bigger and bigger. I think the background is a bit noisy. Can you hear me?
Yes, we can hear.
Yeah. So like I say, you don't need to have a 10 mm contraction joint. You know, if you ask me, a 4 or 5 mm is sufficient. Because why? As the concrete age, the crack width will open up more and more. All right. So if you have a 10 mm, if you open up another 5 mm, then you get a 15 mm. All right. If you put a 5 mm, if you open
Oh, there's another problem with Dr. Zach Lim's line. Eh?
Dr. Zach, we can't see
just now
you.
you lost.
Yeah, we lost you again, Dr. Zach.
Still no? Okay. Yo.
Yeah, now it's okay.
Yes.
Again. I think the
Yes.
line is not
Okay,
too
can see
stable
you.
here now. Now, okay, all right. So just now I say that the saw cut, you don't need to be 10 mm wider by, because concrete will always shrink and the gap will open up. If you have a 4 mm, it's sufficient already. All right, Eric, you don't need to have a 10 mm, because if you have a 10 mm, later will open up to, let's say 15 or 20, isn't it? If you got a 5, it open up to 10, you know, whatever it is. So the width is not important. As long you have a cut, that's all is to me is important. All right.
Okay. Thank you for it.
Yeah. Actually, I've seen some engineers even allow a 12 mm, which is too much. You know, you don't need to have such a big gap because you wouldn't close back. You always open up. That's all. When the concrete only shrink, all right, due to the drying shrinkage, it will continue to open up. Yeah.
Okay, it's almost the end of the session for discussion in this forum. Any other last issue that you want to discuss from the participants, especially? Do you have any issues that you want to discuss? Or maybe you can pause your question later on during the afternoon session, yeah? Okay, you are shy to talk, and please leave your question or issues in the chat box so that we can so that I can ask on your behalf, okay, to discuss on the issues that you have. And then with that, I think we can conclude that this discussion forum we have talked about we have talked a lot about cracks in concrete and the reasons why it happens, right? And then what are the solutions that we can put into the concrete to solve all these cracking problems, especially on due to hot weather concreting and also due to loading. And we have also heard about the very enlightened speech by Dr. Zach Lim, okay, on concrete pavement. Okay, again, I would like to thank all the panelists here, Dr. Zach Lim, Mr. Yeo Shi Hong, Mr. Alex Yap, and also Mr. Eric Sung, okay, for a very active discussion in this forum here. Okay, so with that, I would like to end this session. I'll see you again, and we'll see you again in the afternoon at 2 o'clock after lunch. So unfortunately, the organizer could not provide lunch to everybody. So please enjoy your own lunch, and we hope to see you again in the afternoon. Yeah. Okay. Thank you very much.
Thank you.
Okay. See you, everybody. Bye bye. Have a great lunch. All right.
sorry, 19, 20, 20 bars, sometimes off. So far, it's just some lagging sometimes from the presenters. Depend on chairman. He actually can incite the discussion, you know. Meaning, I think it's going to end like 5 o'clock here. Yeah, I have. Yeah. It's okay, it's okay. It's okay. Yeah.
Hello, Dr. Ahmad. Hello, Dr. Ahmad.
Hi.
Hi.
Hi. So,
Hi, Alex.
Hey, CK. I think is it okay? Is it okay? Violated any rule of Unimas rule or not? Income rule?
No, it's okay. Yeah,
Okay.
I've seen it. It's okay.
Just
No, I've,
a bit of application and what we are doing for concrete product.
Okay.
On this special application of concrete.
yes. Yeah, I'll show it again once we have the free slot later.
Okay. Thank you.
Okay, welcome. Dr. Ahmad, are you the host now?
hi, Prof. Can you
Hi,
hear me?
Dr. Ahmad. Yes.
Because somehow I've been locked out
Are you
automatically.
able to host now?
I think I'm the host. Yes.
Okay,
According
all
to
right.
the writing here, yes.
Okay. Because just now I saw you as the host also, but you said you couldn't take control.
At the beginning, I couldn't, and then after a while, I somehow the role is giving back to me.
Okay, all right. That's good.
Okay, we'll see.
Can you make me presenter, please? I would like to play the
alright.
video again while we're waiting.
All right. Okay, you have the role now.
Okay, thanks. Can you hear the sound?
No, just video, not the sound. How do you switch on the video sound? Yeah, because there's no sound. Oh, no sound here.
Is the sound coming through?
No sound, just video.
Oh, okay. But never mind, the sound is just music. I think they can read the text.
Mm. So I'll let you lead. Yeah. What about are we going to put them all in the panelists?
Not yet, because we will let the presenter present first.
So I'll list some of them into the attendees.
Yeah. Just put the panelists into, just put the panelists.
Okay, okay.
Okay. Good afternoon, everybody. Good afternoon to all the panelists. Hi.
Hi.
Hi, Mr. Yo. And then Mr. Alex Yap, Mr. Eric Song, Dr. Zach Lim, they're all in already. May I check with you, is Mr. Rosley coming in? Mr. Yap, is Mr. Rosley coming in?
Good afternoon, Dr. Eng. How are you?
Hi. Hi, good afternoon. I'm fine, thank you. And you?
Yeah, not too bad, not too bad.
Okay. So there's a slight change in program for this afternoon, yeah? Because I would like to move all the discussion forum to the end of after 4 of you have presented. Okay. So Mr. Yu will present from 2 to 2:30, followed by Mr. Eric Song. So he will present from 2:30 until 3 o'clock. Okay, and then followed by Mr. Yap. So Mr. Yap will present from 3 to 3:30. Okay, and then is Mr. Rosley coming in? Or Mr. Yap, you will be representing Mr. Rosley? Mr. Yap, we cannot hear you.
Hello.
Yes, we can hear you now.
Yeah. Oh, yeah. You'll be coming in. Yeah.
He'll be coming in. Okay.
Yeah.
So I put his presentation from 3:30 to 4.
Right.
Okay.
Sure.
So after all 4 of you have presented, then we have the discussion forum for about half an hour from 4 to 4:30. Then after that, we'll do the closing remarks from there. Okay. So please take note of the slight change in the program now. And then the presentation for each speaker will be about 20 minutes, followed by a 10 minutes Q&A. Yeah? Okay. So first of all, I welcome all the participants to this afternoon's session on the CMS special track on latest development in concrete materials. Okay, so we have the panelists here who are Dr. Zach Lim, Mr. Yo Shi Hong, Mr. Eric Sung, Mr. Alex Yap, and also Mr. Rosley. Yeah? Okay, so in this afternoon session, first presenter will be Mr. Yo Shi Hong. Yeah? Okay, Mr. Yo Shi Hong will give us a presentation on marine concrete, their requirements and tests. So before Mr. Yo start, let me read the profile of Mr. Yo. So Mr. Yo Shi Hong has a master's degree in engineering science from the University of Malaya in 2013. He obtained his bachelor's degree in engineering in 2009 from the same university. Mr. Yo is the director of YSH Concrete Technologies Sdn Bhd, which mainly specializing in special concrete mixes and concrete forensic work. Mr. Yo had worked in numerous projects with various companies. Since 2015, Mr. Yo works as a concrete technical expert for TUV SUD PSB Malaysia Sdn Bhd. In the year 2017, he worked closely with Dr. Ling Eng Hock from Zach Lim Flat Floor Specialist Sdn Bhd on high early strength repair material for smart tunnel. In the same year, he had completed a project in Dalian, Liaoning, China. He is also advising COCO project, Singapore, regarding grade 75 high early strength concrete with low heat properties. Recently, he has participated in a forensic study regarding crack slipper by Bureau Veritas. On Mr. Yeo is also very active in associations and various activities. He is a committee member of American Concrete Institute Malaysia chapter from 2010 till 2019. Furthermore, he is the committee member of the Civil and Structural Engineering Technical Division of the Institution of Engineers Malaysia, IEM, from 2017 to 2019. So without further ado, now I'd like to invite Mr. Yeo Shih Hong to present on his topic on marine concrete, their requirements and tests. So I pass over the mic to Mr. Yeo.
Thanks, Prof. So now I think I would like to present my slide on, okay. This is my slide. Okay, before I start, I would like to thank UNIMAS and CMS from inviting me to give this technical presentation. Thank you very much. So without further ado, I will start the presentation. Today, my topic is regarding marine concrete, their requirement and test. Before we start, I would like to let you know, most of our presentation today is focused on the latest Eurocode EN206 and their requirements. So let's have a look here. Why we need to change the code? Okay, this is quite simple. I believe most of you know this phone is Nokia 3310. It's an analog phone. But today, due to the performance changes, most of your handphone today is smartphone because of the performance and also the requirement. So similar to codes, you need to change, update yourself better performance. So in the latest EN206, they classify concrete strength based on cylinder and cube. This is how they label. So you can see C30/37 means cylinder strength, cube strength, FCK 37. The cube is always almost around 23% more strength, higher strength than the cylinder strength. So other than that, they classify the concrete. Okay, aspect and also the MS EN206, MS 523, but they'll say designated concrete. What is designated concrete? It's a normal concrete for housing construction. For more details, you can refer EN206 and MS 523. Design concrete is what we want to. There is specifier provide the requirement. The producer need to meet the requirement, such as like I'm a consultant, I'm the CNS consultant for this project. I'll tell the ready mix what I need to that requirement, example, which is marine concrete. Then another type of concrete is prescribed concrete. Prescribed concrete is mixed design is given by the specialist, someone like us. They will give to the producer. I will tell them your cement, how much is the content, your water, how much, even type of admixtures. I will tell to the producer. The producer just need to follow what I design. Okay, before I go into this further, I want to come back here because I want to highlight this. There's design concrete, all the JKR project shall design concrete is one of the clause within JKR spec. Please remember, it's called design concrete. So there's another kind of concrete, which is, we call it 1-2-4 concrete mix. Small batches of concrete. That means when you go to the Ulu area, the rural zone, you cannot bring in your ready mix concrete. Then that is the where you need to mix the concrete. You use the 1-2-4 mix or 1-2. I also forget 1-2-4, 1-3-5 or something like that. That is called standard mix. However, in the JKR spec, they also mention only small batches of concrete. You can use this standardized prescribed mix 1-4. Then this is the top secret. I think just now we saw some UHPC, ultra high performance or self-compacting concrete. This kind of concrete we call proprietary mix. That means the producer is not required to disclose the full detail of the mix constituent or composition to the specifier. I have a project similar to SCC or UHPC. My mix is quite unique. I can get very high early strength in 12 hours. There is a project in Sabah. So under that project, my mix is considered as proprietary mix. I do not need to declare to even JKR. JKR will not request me to disclose all the detail. So those kind of mix is called proprietary mix. It's considered special mix because the ready mix or the precaster, they spend a lot of money to do R&D, so they can categorize this mix under proprietary mix. So concrete, how they design. The first thing, they need to know the exposure, where the concrete is. Example, carbonation, like our normal building is designed to withstand carbonation, marine, chemical, and also freeze-thaw. These are all examples. They are examples and not limited to only these four. There are a lot more. So for more information, you need to refer MS 523 or BSF 500. So we talk about materials in conventional concrete. So conventional concrete, you use cement, you use water, you use coarse aggregate, you use fine aggregate, and of course you use admixtures. Then now I have a question. Can we use conventional concrete in marine condition? Okay, the answer is no. Why? Very simple. Can you ask a kancil to actually compete in F1 race? Of course cannot, unless you modify your kancil. That is different story, okay? F1 easily can go up to, I think, 400 kilometers per hour. The car on your right is under McLaren. So same thing, the concrete for marine construction need to be engineered. Okay, according to this code BS 6349 part 1-4. Okay, this is the latest for the British code. The maritime structure or estuarine structure, they are classified as special structure. Please bear in mind, your concrete for this kind of structure are subjected to special loading combined, which is from the impact load, which is from the chemical erosion. So they are categorized as special structure. You can't design the normal concrete and use it there. So this is the exposure categorized by EN 206. Okay, your concrete is subjected to chemical attack on the concrete by the seawater. So most of the type of the agents are magnesium, sulfate, chloride, and even dissolved CO2. So your concrete must be designed to withstand the corrosion from the seawater, withstand the impact. As you can see from this picture, you see how big is the wave. So you must, during you cast your concrete, you must know what type of element, how big is the structure. And selection of good material is very, very important. So for marine structure, you must understand there are different zones. We talk about the simplest, less chemical attack zone or less salt attack zone that is considered XS1, exposed to airborne salt, which is on top of here. It's sea salt only, okay? However, the most crucial actually is not the submerged zone. Submerged is underwater. It's not the most crucial. The most crucial is the tidal or splash zone. Okay, this zone when the water, the tidal, the impact from the tidal or splash, and also the capillary effect of the concrete, the sea salt can be absorbed into the concrete. So during the design of or specify the concrete for marine concrete, the consultant should know what kind of exposure they are dealing with. Please bear in mind, this exposure is very important. We know they're XS class, but you must know what zone you are dealing with. So marine concrete, you use same thing, cement, water, coarse aggregate, fine, and admixtures, okay? But you also might need fly ash. You also might need silica film. You need GGBFS, or sometimes in certain structure, we even put in fibers. So how this mineral admixture works, the silica film fly ash, GGBS, how they work. You see from this is your aggregate. Then this is your OPC. There's still a lot of voids inside the matrix. So after you put in the silica film, fly ash or slag, these SCMs, supplementary cementitious material, actually helps to fill out the void. This is what we call filler effect. Then after that, there's another effect. It's called pozzolanic effect. Pozzolanic effect actually, the SCM actually reacts with the silica film or fly ash or even GGBS with the SCM reacts with the byproduct of cement, which is the calcium hydroxide, to make the CSH gel denser. Okay. This is what I want to show you. The photo is given by our CMS Cement Syndrome Berhad. Okay. You can see on your left side is pure OPC concrete. These are voids, and you have a lot of calcium hydroxide. Okay. Calcium hydroxide is a very weak crystal. And the voids here, because you have a lot of voids, that means your concrete is more susceptible to chemical attack or less strength or lower strength. So on the right side, by just adding 5% of silica film, actually you have removed the weak calcium hydroxide, as you can see. Just a little of, actually you can't see the calcium hydroxide, and you have less void. Actually, you don't even see the dark spot here. These are considered voids here. These are the things cause the porosity of concrete to be higher and make the strength of your concrete lower, which means less durable. So marine concrete for 100 years, can we use SAM1 or OPC a lot? Sometimes it's very sad. I see some mixed design. I see some concrete specifier or the consultants during the specified concrete, they always like to just use pure OPC or SAM1 a lot. But let the courts tell you whether you can use it or not. Okay, this is a requirement I have taken from the latest BS 500-2019, which is a later version than our Malaysia MS 523. Okay, so as you can see, under the latest code, the international code, actually SAM1, you can't put SAM1 for 100 years marine concrete. Totally you're out. Even you use combination of different binder. Here are the different combination. You can refer EN 197. If you have trouble in looking for all these cement criteria, I think our friend in CMS is willing to help you. So these are some of the requirements. Even you use supplementary cementitious material, the minimum concrete cover you need to use is 50 for your info from this requirement. So as the binder content will increase when you go from the right to the left, and the water binder ratio will be decreased. So for 50, that means for 50 mm cover, your grade concrete, this is the minimum concrete grade you must have, C40/50, cylinder strength 40, cube strength 50, water cement ratio is 0.35. That is maximum water cement ratio. The binder ratio is 380. That is minimum binder ratio. Okay, so you can obtain the information by either MS 523-3-2017. For me, this code, even Malaysia standard, is not up to that. This table we are following is according BS at 500-2-2015 plus Amendment 2, 2019, which is up to that. So some of the tests we normally use for marine concrete. Okay, compressive strength test, I think these are some common tests. Then durability test. This is EN 12390 part 8. Just now in the video, one of the presentation video, I think they show you, but now I explain to you. That means you take the cube, then you put under pressure 500 kPa for 72 hours. And under the water pressure 500 kPa, then you crack open your cylinder, you crack it open. Then you go and measure the water depth. This is called water penetration depth of water penetration. For normal concrete, without this pozzolanic material like silica film fly ash, or this one can go 20-30 mm. But with silica film or fly ash, this one might just be, just now I saw from your result, is about 5 mm depth, which is very good for marine concrete. So you also need to do water absorption test according to BS 1881-122, ISAT test. So rapid correct permeability test, RCPT, this is very important test because this is a chloride penetration test. Normally, we want to know how much chloride can penetrate through your concrete. That is what we do, why we do this test. Okay, these are some of the example, a good practice, a guideline from Syria C674, okay, with the test and also the requirements. So this is very important because I met up with a few consultants in Kuching. Actually, they are unaware. They just tell you, I want to do water penetration test. I want to do ISAT test, but they didn't give you what are the requirements. They want to do the RCPT test, but they don't know what is the requirement. Here is a guideline for you. Of course, you can even put 10 mm, but with some reasons, you can even put 0.1 ml per meter square, okay, per second. You even can put that, but what are the reasons as a consultant? These are some of the guidelines. We need to know why we need to put these numbers in. Okay, mass concrete, like Dr. Zack said earlier, we need to control the temperature. For ordinary Portland cement concrete, the maximum temperature cannot be more than 70 degrees. That is under MS 523, okay, or BS at 500. There's a clause mentioning that. So example of temperature monitoring, in the video just now, they also show you, this is one of the example. We do the surface monitoring, we do the intermediate between core. We also do temperature measurement. Of course, please don't forget to take the temperature outside, which is the ambient temperature. The core, and according to SCI mass concreting, the core and external should not be more than 20 degrees Celsius. Okay, what would happen if temperature exceeded the limit? Okay, so you have something called delay attringite formation. Attringite is supposed to be formed very early. However, because the temperature above 70 degrees, the formation of attringite is delayed. When the temperature and moisture, the attringite start to expand. When it expands, the total volume of concrete increase. When the volume increase and the stress is larger than the strength of concrete, it tends to crack. Okay, then this is a very problematic issue. How we diagnose it? Of course, when you put under the scanning electron microscope, you can actually see this error. This is aggregate. This is the matrix, the cement mortar. You can see between the aggregates and the matrix, you can see there's of this delay attringite formation. And if we have a good machine, you can do EDX, energy dispersion, okay, analysis. You also can know inside this attringite. So that is how we detect DEF formation in the concrete. Okay, because concrete we talked earlier is normal. We have ultra high performance concrete application. So what is ultra high performance concrete? It's actually 6 others than normal grade 20. It's 6 times stronger in the modulus of rupture. It has 5 times better splitting tensile strength. It has very, very low chloride diffusion. this material is very good. It's capable of something light and strong. Okay, this is the R&D result, the result from our friend CMS Concrete Products, Sendirian Berhad. Okay, we talk about the normal C20/25, so-called grade 25 MPa concrete. Okay, the most at 38 there you get around 30 plus. Concrete, the most is 55. But with this ultra high performance concrete, these are actual data I got from them, actually with R&D together with them. One day, actually, we can reach 70 MPa. Actually, this is 155 I just used for plotting. Actually, we have higher strength, more than 155. So as you can see, all these are done using local cement and local materials. So this USPC can be used for bridges, can be used for surge barrier or floodgate. It's done in the Netherlands. They are trying to use that for surge barrier. Okay, as you can see from the picture right hand side, it's a combination of concrete, SCC, and fiber reinforced concrete. It's a combination of different kind of high performance concrete. Then it becomes ultra high performance concrete. Okay, that would end the presentation.
Okay, thank you very much, Mr. Yo, for
we go into the Q&A session, Prof.
Okay, thank you very much, Mr. Yo, for your very interesting presentation on marine concrete, which is a very special concrete that we use for the marine environment. So, do you have any question on Mr. Yo's presentation regarding marine concrete and also the ultra high performance concrete? Dr. Ahmad, any question from the chat box?
So far, no.
No, nothing, yeah?
Or we can collect, you can collect your thought and leave it for the discussion later.
Prof.
Yeah, okay. So,
a few special questions for me to show here. Okay, actually, other than this,
yes,
actually, if I want to show hand actually is high performance concrete. Okay, the left side is just the consultant. The left side is 30 MPa at 20. It's a normal grade 5 concrete, but the right side is the high performance or high performance marine concrete. Actually, you can achieve 30 MPa within 24 hours or even more. This is the difference between high performance concrete. I just want to show the participant, all this can be used. You can measure the slump on the right hand side. They are measured by slump flow test, which is Eurocode EN 12350 part 8 slump flow. We measure the diameter. It's high flow concrete.
Yeah, these are the new development in concrete materials, which probably for the consultants or the contractors, we want to show you that these materials and this technology is actually there.
Yes, okay? You even can do it in Kuching.
Yes. These are the new technology that you can make tech benefit of.
Yes. And they always have a question from Kuching. They always ask me whether limestone can be used for the concrete. My answer is I also put here. Yes, you can use limestone in your concrete. Why? It's in the MS 523 part 3 and also the BS 8500 part 2, 2015, 2019. Okay, limestone can also be used as a aggregate for concrete. These are the common two questions I purposely highlight here, even it's not marine concrete. Okay. Okay, that's all for my presentation. Thank you very much.
Okay, regarding limestone, actually
Yes.
some researchers found it has better strength performance as compared to
Yes.
granite actually.
Yes, correct, Prof. This is very indeed correct. We have tested in the local testing lab.
Yes, yeah.
We
Okay,
even can get 40 MPa within 24 hours with limestone concrete.
yeah, yeah. Okay, any question from the floor? If not, probably you let all this thought settle down first, and probably during the discussion forum, you can ask back the question. Huh?
Okay, no problem.
Right. Probably we move on to the next presenter here for today.
Yeah.
So our next presenter will be Mr. Eric Sung. Huh? So Mr. Eric Sung will be presenting on the topic of decorative concrete fretworks, what engineers and architects need to know. I think this topic is very interesting. Yeah? Okay. So Mr. Sung has 12 years of working experience gained in Australia and Malaysia. He graduated with a Bachelor of Mechanical Engineering from University of New South Wales and a Master's in Environmental Engineering from University Technology of Sydney. He is highly experienced in the installation processes, pattern designs, and has expertise and knowledge in providing on-site solutions to issues relating to decorative concrete floorings. He has also successfully led teams to complete and hand over decorative concrete projects around the country. Eric is also proactively working with the manufacturing arm to explore environmentally friendly decorative concrete paving products. So without further ado, I'll pass the mic over to Mr. Eric Sung for his presentation. Yeah, so Mr. Eric Sung, please, the floor
Hi.
is yours.
Thank you, Professor. Thank you so much for introducing me. Okay, so let's first of all, I just would like to thank UNIMAS and CMS as well for inviting me to share some of share my slides today, actually. So let's start off with how decorative concrete came about, actually. So it's been around actually for a very, very long time. So during the Roman times and also during the Italians as well, used it a lot to decorate places of worship, actually, and also places where they think it's high affluent places as well. So actually, the landscape architects are one of the huge drivers of decorative flatworks. But why concrete? It's because concrete has a very unique ability to work on, even when it's hardened or during its fresh state as well. So we can do a lot of things with concrete, actually. And the other reason is because it's also very durable as well, and it's very versatile. So just broadly introduced to you like a decorative concrete flatwork is that it can be broadly broken down to 3 different types, actually. So one type is what we call a fresh concrete finish. So where actually the works are done when concretes are still fresh. You can actually also work on hardened concrete as well. So you can actually decorate concretes after it has hardened. And the latest technology with decorative concrete is actually using overlay finishes on the surface of concretes as well. So there's some few things that we have to look when we look at decorative concrete. So one important element that we need to look at is the sizes of aggregates in the concrete mix, and also the cement content and the type of cement that's actually used in the mix. Water content is very important as well. normal concrete as well as decorative concrete, water is in the mix is very important. And then we look at slump as well, because especially for works in fresh concrete, we have to use slump to control workability. And also the most important thing is coloring. Coloring in decorative concrete is very, very important as well. Okay, so when we look at the decorative flatworks, so what we look at is it's actually textures going onto the concrete surface actually. So aggregate sizes plays a very important part. Like we said, that textures that are more than 6 mm imprinted or actually going onto the surface, you would actually have a, I would say a maximum size of around 20 mm, or anything that is more than 6 mm deep textures that's being onto the surface, then you would have to have smaller nominal maximum size aggregates. Now that would actually promote better finishing as well. And in terms of cement content, it's arguably one of the most important element actually in the decorative concrete mix. Generally, we actually look at SEM1 and SEM2 sort of cement types in the concrete mix, but in decorative concrete, we generally prefer SEM1 concrete mix actually. While we understand that the SEMs can improve very much the durability and what we say the workability, but what happens is that SEM sometimes, right, it will actually affect the colors that's actually going into the concrete. So we try not to actually use SEMs, but rather just use pure OPCs in our concrete mix. Okay. So as we talked about earlier, what water content is very important as well. There are a few items that in the decorative concrete that we do not want to see is excessive water bleeding, meaning you have high water content and low fines in the concrete mix. But what you want to see is something like that is just nice, a little bit of a bleed water. So, and the concrete is definitely very workable as well. So that is some of the parameters that we try to look at when placing fresh decorative concrete. So as we heard earlier on, if there is a lot of bleed water, sometimes we have an effect called dusting as well. And this is what we don't want to see in a decorative concrete finishing as well. So what do we want actually? So what we want is a very nice surface where the imprints are well done, textures are gone in well. So there are some parameters that we look at to give longer term durability, and this is some of the recommendations that we used to share with architects and engineers as well. Certain parameters that we look at, especially in terms of the cement content, we look at around a minimum cement content around about 320. That gives you a fairly rich concrete surface mix. And then when you are actually doing on the surface finishing, it will actually promote better finishing in the surface. When we look at the water ratio, we try to cap it as well. So we're looking at no more than 0.55. And one of the most important things working on fresh concrete, especially in decorative concrete, is that you want the mix to be workable so the workers can work it well and all that. So we're looking around about a slump of, well, I say around 125 plus minus 25. And we look a workability that's maintained on site of around about 1 to 1.5 hours. So we got certain guidance as well, how we came out with minimum cement content and all that. One of the source is the MS523 as well. So we looked at the minimum cement content that is required from the guide as well. So because most of the flat works are actually carried out outside in the external areas, so we have actually cyclic rains and winds as well. So we look at the nominal cover of roundabout in the XC 3 to 4. And if you look at it, the minimum recommendation is around 300. But because if it's a decorative concrete mix, we want it a bit richer. So that's why we recommend it to go a little bit higher than the minimum recommendation in the standards. And in terms of workability as well, what we found is if it's around 125 plus minus 25, right, then there's a tendency of workers try not to add actually water into the mix as well. So this is actually in the MS standards as well. So we found out that in the standards that they actually are looking round about 100 to 150 as well. So what we're saying is that this kind of slump will be good for decorative flatworks as well as non-decorative flatworks as well. So now we come to one of the most, I guess, the most important element in the decorative concrete, which is coloring, right? So coloring is like, I'll give an example, like in nasi lemak, right? Like the sambal. It's very important there, right? Because it gives you life, it gives you flavor, and it gives you the extra edge actually. Now, coloring is the one that gives it extra edge to non-color floors as well. So coloring is one of the I would say the most important element, is because like it is the first thing people will take notice actually. And when it comes to coloring, pigmentation is very, very important as well. So there are a few ways where we can actually add colors. So you can actually add colors when the concrete is still fresh. And you can also add colors as well when the concrete is hardened. But I just need to stress that especially colorings in decorative concrete, it's very hard to achieve what we say color consistency as well. Even from the same truckload, right? You would get minor inconsistencies in colors. So when we come to pigments, right, the most common type that is used is actually the inorganic pigments that we use. So what we say is that typical loading is around 2 to 10% of the binder content actually. So the loading varies. Like when we say darker colors, just say for black pigments, right, you can actually reach saturation at a lower loading rate. But if you go to like say a blue pigmentation, then you might need a higher loading rate in order to reach a saturation point. But all in all, we are actually looking at about 2 to 10% of the binder content actually. But why inorganic pigments, right? Because inorganic pigments they're actually insoluble, and it's a very good resistance to fading when exposed to weather. We have codes as well that most pigments that are actually added into the concrete should comply with the BS EN 12878. So how does cement influence color concrete actually? One thing is that gray cements, right, they tend to be more suitable for colors that are darker. And then if you want to have lighter, more vibrant colors, right, usually you have to add in white cement inside as well. But cement content as well, right, would actually play a very important part of how strong the color will turn out and the increase in color saturation as well. As you can see in the slide, we have a concrete of around 280 kilograms per meter cube. But when compared to a concrete about 320 kilograms, you can see the colors are a little bit stronger compared to a lower cement content, sorry. And then we come to water as well, like how water content actually affects the end product of the concrete. Too high of a water content, you will actually get lighter colors. Now, this is simply because as you have more water coming off, evaporating from the surface, then you would actually have tiny spots and tiny bubbles, and that would actually scatter the light. So when lights are scattered, right? So what happens is that concrete becomes, or the perception of color will become lighter. So that is why when we talk about water content in color concrete, we would actually tend to limit it to a certain WC ratio as well. So as we said before, there is two types of ways that we can actually add colors into concrete. One is actually the ways is like we actually broadcast color hardness onto the surface of the concrete, and the other one is actually adding pigmentation into the concrete itself. So dry shake hardness that actually added through handshakes and also machineries as well. So they're actually made of cement, fine aggregates, and also pigmentations as well. So why do we use dry shake hardness? Is because that it gives you a more vibrant colors compared to when you're coloring the concrete itself. And the other thing about color hardness is that it creates a denser and a more abrasive resistant concrete surface as well. So here we have some photos of how color hardness are being applied onto the concrete surface. And the other method of coloring concretes, right? We actually add in colorants or actually pigmentation in dry powder forms into the concrete mix itself. But these are more towards earthly tones and also darker tones colors. So as you can see on the left-hand side here, this is how the entire concrete can be colored. And on the right-hand side is the example of how concrete is colored actually in the batching plant. And by the time it actually arrives on site, the whole concrete is actually colored already. So as we said before, there was two ways. Another way of coloring hardened concrete is when it's hardened as well. So how do we do this? Is that we can actually use color stains, tinted coatings. So these can actually add color effects onto hardened concrete as well. So these are examples of some of the concrete that is actually colored post concrete, meaning that when it's hardened, then we actually add in the colors onto it. So I'll just run quickly into some of the concrete flatworks that are actually available actually in the market. So one of the most seen, I say, is the stem and textured concrete that you can actually see well in most residentials and also commercial projects as well. So stem concrete is a process where we actually use prefabricated molds, and then we actually impress the molds onto the surface. Textured surface is similar as well, but you actually use tools to create the textures on the surface. And one other method of decorative finishes on fresh concrete is by exposing the concrete surface as well. So these are some examples of how pattern concrete is done. So you actually use prefabricated molds, and you actually imprint the the designs onto the surface before the concrete is hardened. So these are some examples of completed projects as well. So the finished product can actually replicate a lot of natural materials. For example, granites, stones, wood as well. So when it comes to textured finish, you can actually use tools to actually create textures on the surface. So for one example, on the left-hand side is we actually use a special type of groover where we actually cut through the concrete surface and leave it for as a finishing. And on the right-hand side, we actually using actually rock salts actually to create patterns on the concrete surface. So what we have as well is that you can actually have light bloom textures, and even wood trowels can actually be used to create patterns and designs onto the concrete surface. One excellent way of decorating concrete is also exposing aggregates as well. So what we can do is we can actually use a lot of materials where we can actually use recycled materials. We can actually use sand as well, that we can actually expose this top surface so that you can actually see the beauty of the materials underneath the concrete cement matrix actually. So these are some examples of the final products of exposed aggregates. Another way, as I talked earlier, some of the decorative finish can be done on hardened concrete as well. So one very popular option now is actually through grinding. So when it comes to grinding concrete, so you actually use mechanical means to actually remove the top surface of the concrete. And in the United States, the Concrete Polishing Council actually has a guidance of what sort of class can be classified in grinding concrete. So one examples are like on the right-hand side is where you actually polish the concrete, so the sheen is actually natural. And on the left-hand side is actually very light surface exposure, and it's finished with concrete sealers. Another way of decorating hardened concrete is actually through scoring and also through engraving as well. So this is an example of a project where the lines are created through cutting, and you can actually have special tools to actually engrave logos or patterns onto hardened concrete as well, which is seen on the right-hand side. So as we talked about earlier, some of the latest trends in decorative concrete is actually using concrete overlays, where you have a higher performance material that's actually overlaid onto the surface of the concrete. It can be polymer modified, or it can be resin coatings as well, like epoxies, polyurethanes. So these are some examples of cementitious materials that are actually used to decorate the top of the concrete surfaces. And these are some of the resins that can be actually used to decorate hardened concrete as well. So on the left-hand side, it will be what we know as metallic epoxy coating, and on the right will be polyurethane coatings. Yep. Thank you again for the opportunity today.
Okay, thank you very much, Mr. Eric Song, for a very interesting presentation on decorative concrete. So in fact, we can use concrete to make whatever shape, whatever color, whatever texture that we want through all the research and development in making decorative concrete. So
Yes, that's very correct.
Yeah, and there's a question here on whether there's environmental impact if we use colored concrete, if leaching happens.
No, actually, what happens is that because the pigments actually binds into the cement matrix, so what happens is that the cement itself will actually shield the material from being blown out, being leaching out, and all that. So one other thing is that the pigments that are used are actually insoluble. So that's one good thing about inorganic pigments. So it would not terribly affect the environment, actually.
Okay, thank you very much for the answer, Mr. Song. There's another question from the same person who is Mr. Muhammad Jamil. So his question is, how durable is decorative concrete?
How durable? Okay. Actually, decorative concrete is as durable as any other type of concrete as well. What we are actually achieving in decorative concrete is mostly decorating the surface of the concrete. But in terms of the durability, the strength of the finishing actually comes from the concrete mix itself, actually.
Okay, thank you very much for the answer, Mr. Song. There is another question from Mr. Rosli Idris. So in general, what is typical dosage of pigment in colored concrete?
Typical dosage, actually, we look at the different types of colors, actually. So as I said earlier, darker colors you would need less pigment loading. So, but the typical we are looking at is round about between 4 to 6% at the optimum rate.
Okay, thank you very much. So there is no other question from the audience. I have a question for you, Mr. Erickson. By adding pigments, will we alter the properties of the concrete? Any effect on the strength and also the slump of the concrete?
Right. So far, what we're saying is because the pigments are actually very micronized, so they're actually smaller in terms of cement sizes. What we found is that when we are doing the experiment, there is no changes when we add pigments in terms of strength and durability as well.
Okay, thank you very much for the answer. There is another question from the audience who is Mr. Azman Haimi. So his question is, can color concrete be polished? And how long the color will last?
Yes, color concrete can be polished, yes, because polishing is actually a mechanical process as well. So, but in the end, what happens is that polishing will create a very dense surface. So, a short answer is that yes, it will be kept for quite a long time as well, especially a polishing concrete is because you are creating a very densified surface.
Okay, thank you very much, Mr. Song. Since time is running out already, so I think we'll have to end Mr. Eric Song's session here. So thank you very much, Mr. Eric Song, for your presentation and also your answers to all the questions that we have posted out. Okay, thank you very much again. We have our next presenter, Mr. Alex Yap. So Mr. Alex Yap will present to us a topic on role and trend of chemical admixture. So Mr. Alex Yap graduated with degree in Bachelor of civil engineering with honors and started off his career as a project engineer in the heavy industries. He is now specialized in concrete admixture and also the lead for MBSM, precast and underground segment with experience of various mega projects from high-rise building, infrastructure to hydropower project in Malaysia, as well as concrete-related research projects. Currently, Mr. Alex Yap is the Executive Committee member of ACI Malaysia and Associate member of MBAM. So without further ado, I'll pass the mic to Mr. Alex Yap for his presentation.
All right. Thanks, Professor. Yeah. So can you guys see my screen before I start? Hello?
Yes, we can see yours. We can see
You can see
slide.
it all.
Yes. Yes.
All right. Yeah. So before I start, I would like to thank also Unimas and CMS for inviting me. Yeah. So it's been an honor to be able to share some of my experience in concrete images. Yeah. So before I start, I would like to highlight few challenges that the construction nowadays they're facing. So the first one, I think, construction nowadays we want the construction to be fast. Yeah. So instead of constructing 2 years, we want it to be done by 1 year. Second challenge will be the carbon footprints. So right now, green building being iconic and we are concerned on the greenhouse effect. Yeah. So the third will be the cost. Yeah. So right now, instead of 1 ringgit to do, we are expecting 0.8 to complete a task. So what I want to highlight is by using admixtures in a way we can resolve or reduce some of the impact. Yeah. So before I start, what is chemical admixtures? So chemical admixtures, you can see here. Yeah. Some people say it's a magic water. You put in concrete become very soft. Yeah. But what it really means. So under this EN 934, any these admixtures other than water aggregate and additives such as these mineral admixtures we call, yeah. So and fiber reinforcement is categorized under these, chemical admixtures. So these chemical admixtures will enhance the fresh property and harden stage of the concretes. Yeah. All right. So why we need to use admixtures? Why we do not want to stick back to 124 or the olden technologies? Because I think we have to counter three main challenge that right now we are facing. Right now is concrete nowadays. We want it to be fast. Yeah. Second thing, the concrete become more durable. We emphasize on performance, and then right now a lot of skyscraper projects that we are doing. So without these admixtures, this skyscraper project can't be even achieved. Yeah. So right now the challenge on high-rise building is not about casting concrete on the flat level. It's about going vertical. So all these buildings they require concrete to be pumped 500 meter vertically. So you can imagine what's the stresses that they are facing. Concrete. Right. Yeah. So in concrete admixtures, we are no longer just normal water reducing admixtures. Right now, we have a lot of series of admixtures. So for example, right now we have ENCON, which is not very popular in Malaysia because ENCON mainly is actually used on fish and to encounter fish and tow. Second is the water reducing admixtures, which is what we are using normally. Yeah. Third is accelerating admixtures. Fourth is retarding. Fifth is hydration control admixtures. So one thing to highlight about these hydration control admixtures, right now we have these admixtures have a technologies to actually put concrete into sleep. So what I mean in putting concrete into sleep is that you can actually put these chemical admixtures into your concretes, leave it for several days. You put activators actually can activate back the concrete, and then you can reuse back, you can use back the concretes as normal casting. Yeah. So 6, we have corrosion inhibitor. 7, shrinkage reducer. 7, 8 is alkali silicate reactivity inhibitors. And 9 is what just now what Eric have actually mentioned, the covering admixtures. And other than that, it's all fall under these special admixtures. Yeah. So today I will only highlight on one key topics on the chemical admixtures, which is the dispersion admixtures, or what we actually know commonly say is the superplasticizer admixtures or water reducing admixtures. So what is actually under this ASTM C494? So actually these admixtures are actually categorized under these 8 categories. So type A is water reducing admixtures, type B retarding admixtures, type C accelerating admixtures, type D water reducing admixtures plus retarding. Basically it's the A and B combined. So the rest as following. So I won't really go through the details. But what happened is I would like to highlight also the developments on these admixtures. So on the olden days, yeah, so lignosulfonate is actually a very popular chemical admixtures. 1950s go to 1970s is actually developing. We have this melamine sulfonate, but this melamine sulfonate is not really popular in this ASEAN region due to some negative effect on this chemical mixtures. So coming to 1970s, we actually have developed this another series of admixtures which called naphthalene sulfonate, which short term we call BNS based admixtures. So on the 1990s, we have, and then 2020s, we have this PCE based admixtures, which is the polycarboxylate admixtures. Yeah. So as you can see here, so the range for lignosulfonate is actually the normal plasticizer, which the water reduction effect of 15%. Superplasticizer is around 25 to 30%. So hyperplasticizer, the water reduction effect can go up to 45% or even more. Yeah. So before I go into details, let's see what is actually all these chemical admixtures. Yeah. So for lignosulfonate, where does it come from? It's actually coming from this paper industries. Yeah. So this lignosulfonate is not least popular nowadays. Second will be the naphthalene sulfonate. It's actually coming from this sulfonated naphthalene-based chemical. And what happened is it has lower workability retention compared to PCE. And then the negative about this BNS is if let's say you use more, it might cause delay set, yeah, compared to PCE. So PCE is what we call polycarboxylate ether. It's actually latest. I would say it's considered the not the latest version, but the second latest version of these chemical admixtures. So what happened is these PCE admixtures, what makes things interesting is these PCE admixtures can be customized. And then the water reduction can be as high as 45%. Yeah. So compared to BNS, this PCE has a faster setting time. And then the second thing is it will actually have a higher early strength as well. So, okay, so how does this, so the next question, how does this admixtures work? So before I go into it, I think just now, you all have actually highlighted the picture number A, this one we call A, and versus number B. A is no longer, we can't really measure the workability using strength, yeah? So in all this, people say, okay, I have a very flowable concrete. They will presume that this concrete is having low strength. Whereas this kind of concrete, they will prescribe as a very good strength concrete. But with current technologies, we can make things, with this concrete, you can achieve even a better performance, or I would say a better strength concrete versus this, yeah. So what's the main role of this, what we call sizing admixtures? Actually, there's a three main rule here, yeah. So after you add this, first thing, after you add this, what we call chemical admixtures or water reducing admixtures, without adjusting any other properties, the concrete will be more workable. So what do I mean by concrete become more workable is your concrete, you can see number one, your slump, for example, from 100 will go up to maybe 120 or 150 without affecting other properties. So if let's say you are targeting grade 40, so we measure, when we measure by on this water cement ratio is when you have lower water cement ratio, you have higher strength. Yeah, that's one thing that we need to keep in mind. So what happens is you can actually maintain your strength or your performance of concrete while improving your slump of your concrete. That means your workability of concrete. Your concrete become more easier to be placed. Yeah. So the second function, after you, if let's say you just want a slump of 150, yeah, you can actually use the water content in the admixtures. So what happens is, if let's say you reduce the water content in the admixtures, what happens is your water cement ratio will actually go lower side. So by going lower on water cement ratio, you will actually achieve a higher strength of concrete without affecting other properties. That means if let's say you're targeting 150 slump, you will be still able to achieve 150 slump, but at the higher strength. Yeah. So third, what make this admixture interesting is that you can have these two properties together. So you can actually, instead of you wanna go into the center part. So what I mean is you can actually reduce your water and cement together to achieve the same properties. So by reducing these two, you have two main impact. One, you reduce cement, you reduce the carbon footprint. And then by reducing cement, you actually save money. Yeah. So yeah. So next is yeah, right. So this is what we want to achieve. Yeah. So, but of course, without proper mix design, you can't actually cut the cement like what we expected. I mean, like what we want. Yeah. So actually, if let's say you want to cut a certain dosage, or if let's say you want to adjust your mix design, you have to come up with several tests to actually confirm the performance. But in general, you can actually add these admixtures to achieve these two properties. Yeah. So which is to help you, is not only to reduce the carbon footprint, it also help you to save costs. Yeah. So, and I also would like to highlight that just now when we mentioned about these lower peak temperatures or even high performance concrete. On peak temperatures, one thing we need to be very concerned is on the cement content, because cement will actually generate heat due to the hydration process of the cement. So what happens is you need these admixtures. If let's say you use the rack mix, the racks admixtures, you actually can give you the very optimum mix that able you to achieve the peak temperatures that you desire. Yeah, but of course, this one is just one of factors. So how does this admixtures works? So in general, when you put cement with water, what happens is this cement will actually flocks together. This cement particle you can see. So in the middle, we have this entrapped water. This water has been entrapped, and then this without admixtures, this entrapped water can't be dispersed out, and then your other cement particle can't be really absorbing this water to be fully hydrated. So on the for these normal admixtures, what happens is these admixtures actually induce the negative charges to all the cement grain. You can see here, yeah. So after you added these chemical admixtures, the cement grain will be coated with a negative charges polymers, yeah. So what happens is when you have negative charges, two negative charges particle to on these negative charges particles will actually repel. So when these two particles cement grain repel, you will actually release water, which is entrapped in the middle. Yeah. So when these two particles, all the cement repel, the water will be released. So this water can be react to on other cement particle. Yeah. But of course, after several times, these negative charges will be disappear, and then this CHA gel will actually absorb. I mean, it will actually be crystallized. Once cement grain has been crystallized or have fully hydrated, these negative charges will be actually been absorbed. Yeah, to form this what we call CHA gel. So microscopic, you can see this cement is without adding admixtures. So you can see a lot of lump cement grain has been lumped together. So, or what we call flux, yeah. So the other one, you can see after you add in admixtures, the cement particle has dispersed. So you have more water to react with other cement paste, your concrete become more workable. That's the very general idea how admixtures, chemical admixtures work. So when we come to this, what we call PCE or polycarboxylate ether admixtures, which is the third generation of these chemical admixtures, what happens is these polymers not only have charges, what we call just now what I have actually explained, the negative charges, it also have this side change, which give the flexibility or of this PCE. So I will show you what do I mean by the flexibilities. Yeah. So this core polymers is what we call the main chain. The side chain, we actually can customize this PCE to different project requirements. Yeah. So if let's say for example, we are dealing, we have to focus, I mean, some of the precasters that need strength. All these side chain polymer can be adjusted to fulfill the requirement. Yeah. So if let's say this project require retention, slump retention, which is I think just now CFI actually showcase 8-hour retention. This polymer can actually be customized to the local needs to fulfill the project requirements. Yeah. So this is what I mean by tailoring the admixtures. So if let's say you need a high water reducing admixtures, you can actually place in different type of side chain that you require. If let's say you need a high early strength admixtures, you can actually adjust the side chain of this polymer. Yeah. So that's why this PC technologies has been in the market for so long, because of one of the very interesting about this polymer is it's very flexible. Yeah, you can actually keep it customized. So if let's say, for example, this is one of the projects, yeah, that require fibers. So these projects, that not only required to have the cohesiveness of the concrete, it also require the early strength. So what happened is one part from this admixture is you can actually request the chemical supplier or admixture supplier to customize based on your requirements. If let's say you need 1 day 20 MPa or 1 day 30 MPa, you can actually request them, okay, this is your requirement. You need this 30 MPa in 1 day, and then you are adding these fibers, and then you are expecting your concrete to be cohesive. It actually can be done using this PCE technology. Yeah. So on this third gen of PCE, it actually have another effect is what we call this slump retainer effect. So on normal PCE, without the modified PCE, the slump will actually lost within 30 minutes to 1 hour. What I mean is it will actually drop. That means your workability will actually drop starting from 30 minutes to or up to 1 hour. Yeah. So your slump maybe from 100 will drop until 80 or 150 to 130. Yeah. So with the newer modified version of this PC, it actually can retain your workabilities over a certain period of time. So this is how the normal, what we call the super plus slump retention, I mean the effect. Yeah. So on the early stage, it will have a very high slump. After 1 hour, you actually basically lost the workabilities. Yeah. So with the red color is what the normal what we call the normal market practice, which we add retarder. So retarder is actually to prolong the setting time. The second is actually to prolong the working time as well. So what you can see here is it's actually by adding a little bit of this what we call retarder, it can actually further extend the working time or the workabilities of the concretes. So by using this what we call the modified PC for slump retention, it actually can maintain the workabilities for server for a specific time zone. So what make things interesting? One of the things that I would like to highlight is that with these technologies, you do not need to worry on rejecting your concrete. Yeah. So for example, if let's say you are facing a very heavy traffic, or you are facing your concrete required to travel long journey. Yeah. So from batching plant to your site, maybe you require 3 hours. With normal retarder, it might not able to achieve it. Yeah. Or you can achieve it, but there's a certain risk that you have to take. Yeah. But if let's say you're using this slump retention, you can actually guarantee the quality of your concrete. Yeah. Okay. So this is a clearer pictures. So a lot of what I say is the conventional additive, which is the first gen or the second generation of admixtures, the workability will actually drop. But most of the times, our requirements, we are expecting concrete to work 3 hours or 4 hours. So how can a conventional concrete to achieve it? So most of the time, what happen is, if let's say the site, they want to achieve back or they want to gain back the workabilities, most of the time in two ways. Either you add water or you add admixtures. But we know that if let's say you add water, what happens is your concrete strength will be affected, or you have to compensate your concrete strength, which is not good. Yeah. So the other one is you add admixtures. By adding admixtures, it will actually it can be done, but it requires a little bit of uh, 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 the technical know-how, yeah, to add. So if let's say you want to have a worry-free concrete, so what happens is you can actually request the chemical supplier or your concrete supplier to have this concrete that can actually maintain the workabilities for up to 8 hours in Malaysia. Just now, I believe CMS also able to do it. Yeah. So you can actually maintain the workabilities, your concrete still workable in time. So one of the I would say few years back, the iconic projects that have been done using these technologies is this Penang Second Bridge. So during that time, this one is one of the longest concrete retention time that have been achieved in Malaysia, which is up to 8 hours. Yeah. So that means your concrete can be workable this 8 hours of time frame without affecting on others properties. Yeah. All right. So I think that's all for my side. Thanks.
Okay, thank you very much, Mr. Alex Yap, for a very interesting presentation on the role of admixture in concrete. So, is there any question from the floor regarding the presentation of Mr. Eric Yap on concrete admixture? It's very interesting to see that nowadays you can actually customize or tailor-make your concrete to suit your practice. Okay, by using this customizable admixture, which is polycarbonate ether-based admixture, especially.
Yes, yes, yeah.
Any question from the floor? Dr. Ahmad, is there any question from the floor?
No, so far. No question.
Oh, nothing so far.
Yeah.
Okay. If there is no question, then I would like to ask a question regarding this chemical admixture. So if let's say I want to achieve a very high early strength, so what kind of customized admixture would I need to use?
So for I would like to highlight again. So of course, other than admixtures, to do what we call high early strength or UHPC products or high early strength products, we can actually customize the. You have to use PCE based on the shorter side chain polymers. We actually can be done. So if let's say you require it, but we need to know what's the early that you actually define: 6 hours, 8 hours, or 12 hours, or 1 hour. So that one is just one part of it. I think the second thing is need to highlight is the mix design also play a main role. So admixtures is actually to customize based on your requirement, but I think the overall mix design is the I would say is the meat lah. This one is just one of the ingredients. Yeah.
So let's say if I want to have very early strength, even though if I use fly ash and slag in my concrete, is it possible?
It depends on the percentage. It actually can be done, but for fly ash, if let's say you use a very high percentage, it's actually a challenge to be honest. Yeah, especially fly ash. Yeah.
Normally, fly ash we use up to maximum 30% of replacement.
Yeah. Yes. Correct. So it depends on the early strength. So if let's say you need 1 day, then you put 30, it might actually eaten up a little bit of your early strength.
Yeah. But is it possible to alter the mixer by using the PCE admixture? If I still want to use I still want to achieve early strength.
Early strength, I would say it can be done, but I think the customization have to take in place lah. That means you have to do quite several this R&D to able to achieve it. Yeah.
Okay.
Because the different type of PCE also will actually react differently with different source of material. Yeah.
Yeah, it's a good area of research actually. With high replacement, but we still want early strength. Okay. It seems like there is no additional question from the floor. So thank you very much, Mr. Alex Yap, for your presentation on the role of admixture. And also thank you very much for answering my question. And then the next, we will have the next speaker, who is Mr. Rosli Idris. So he will highlight the title of how self-compacting concrete can benefit Sarawak construction industry, which I find quite interesting. So before we start, let me read out Mr. Rosli Idris' CV. So Mr. Rosli Idris graduated from Okayama University with master's degree in civil engineering, and he started his work as concrete engineer at Japan for 10 years. Mr. Rosli has over 30 years of experience in concrete technology, and now he is the head of construction for admixture system in MBSM, Malaysia. His continued interest to contribute to the construction community continues today and throughout his career. He regularly supports causes involving the concrete industry. So without further ado, now I will pass over the mic to Mr. Rosli for his presentation.
Professor Ng, I think I will share my screen. Yeah. Can you pass the presenter?
So moderator, can you please pass the presenter right to Mr. Alex Yap?
Sure, he's done. So Mr. Alex is the presenter now.
Okay.
No. No. Okay, I open my speaker here. I open my speaker.
So Mr. Yap, you can share the slide now.
Yeah, I'm sharing the slide. You can.
Okay.
You guys can see my slide?
Mr. Yap, we still can't see your slide. We are still seeing your webcam image.
Can you guys see my screen?
No, we're still seeing your webcam video.
Webcam. Okay. Sorry, I have a technical error.
Probably while waiting for Mr. Yap to sort out the slides, so if there is any question from the floor, probably you may ask even the question to the previous presenters. I think there's a few questions that I saw that we'd like to ask to the to Mr. Yo.
Okay.
So the question is from Mr. Muhammad Jamil.
Yes.
So his question is marine concrete costly compared to conventional concrete? Probably what it means is UHPC, you know? Okay.
Okay. We talk about the general marine concrete first. In practice, actually marine concrete actually consists of either OPC, fly ash, silica film, and also slag GGBS. Technically, the total cost of the concrete per meter cube is not very expensive. However, why the customer, I mean the producer, is charging at a premium rate? Because they need to do a lot of R&D. They need to do a lot of R&D to get the outcome. That means the water penetration, the water absorption, the rapid correct penetration, and also there's another ISAT test. So that is the reason it is so expensive. For your information, our normal grade 50 concrete in KL around 250 ringgit. Okay, that is the previous a few years back the price. But marine concrete at that time, they are selling more than 500 ringgit, almost double. But if I compare the mixed design, of SCM, they use a lot of this silica film fly ash or slag. Actually, the total cost actually, in terms of material alone, is not very expensive. They are expensive because they are performing. Just like you are using a BMW, Ferrari, say, but the normal OPC concrete, you cannot reach that spec. Just like what I mentioned, MS523 Part 3 or the BS at 500 Part 1, the 2019 Amendment 2, actually OPC cannot do the work. That's why you use marine concrete. So we can't compare apple to apple, the first thing. But I can sure, like what Alex mentioned just now, marine concrete is a low carbon footprint concrete with suitable admixtures, yes. And if you are talking about UHPC is a proprietary mix. We spend a lot of time doing R&D and depends on location. Some location, the pricing is not expensive. Example here in West Malaysia with a company called Dura, okay? Because of the location and they have the aggregate there, nice aggregate. So overall, per meter cube price is not so expensive. I believe in Sarawak we can do that also because we have plenty of natural resource down there. So price of these high performance materials, we cannot compare apple to apple like normal concrete and all this marine concrete or UHPC because they are different. We cannot use a rocket price compared to a normal kancil. That's what I want to mention here. Because of performance is different. I hope I answered your question.
Okay, thank you very much. I think the answer is yes, it's more costly, right?
Performance.
Yeah, you pay the price for the performance.
Yeah.
Yeah.
Sell according to performance, not according to material.
Not according to
Prof,
material
this one is
cost.
very important because we are designing special concrete today. We are not talking
Yes,
about
yes.
the designated concrete anymore.
Because it's not the cost of the materials per se, but it's the cost of R&D that we put in,
we put a lot of effort.
The time and effort that we put in, yeah.
Yes, agree.
Yeah. Okay, Mr. Yap, have you got the slides sorted out?
I think I can't share my screen. Wait, because I tried to share, but it did not. You guys see my screen?
No.
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 I think, can you guys wait me for a second? I think I will re-log in back this, right?
Okay.
Okay. Yeah. So while waiting, I think there's another question to Mr. Yo on your marine concrete.
Okay.
So the question is also from Mr. Muhammad Jamil.
Yes.
So the question is, do you have actual project using the marine concrete mix design? Yeah? And how is the outcome?
I can say it can 100 years, but according to the court, it should last for 100 years. What we always concern, but I will tell you, based on what I see, because that project, there's one small mistake part, then the part is eroded. Then compared to the actual marine concrete, the marine concrete is still there. The surface is still very smooth. The normal I can say compare like that as far as I know.
Okay, thank you very much, Mr. Yo, for your answer. And I think there is another question that is, I think both Mr. Yo and Dr. Zack Lim can answer. So this is also from Dr. Muhammad Jamil. So his question is, what is the benefit to JKR of using UHPC in road applications such as the concrete road pavement?
I will answer
Using
the
UHPC
first.
in road pavement.
Okay, I answer the first part first. We don't use for the topping. We don't use for the whole stretch of road. Normally, UHPC we use for the topping, for the bridges, or the girder of the bridge. Example, if you are using UHPC for normal beam design, the like our King Center there, the flyover, that is considered normal beam design. That one, every 30 meter, almost every 30 meter, you need a foundation. I mean, you need the bottom, the foundation, the piers. But with UHPC, actually, almost double, I can say. So almost double the length, you only need a foundation. And there is West Malaysia. They mentioned that actually, if you are using UHPC, save of the piers or the foundation, and also the cranes and machineries, you actually can save almost 30% of the flyover bridges. In UHPC, you can construct very easy because the machinery is you do not need very heavy machinery. You just need a very light machinery because the structure is thin and light.
Okay, thank you very much for your answer, Mr. Yo. Dr. Zack
Okay.
Lim, do you have anything to?
Yeah, Professor.
Yeah.
Yeah, to add. Okay,
Okay,
regarding the for the floor slab, using UHPC, you can even reduce your floor topping to as thin as 10 mm. Yeah. We have actually done floors where we want to top over an existing floor. We can do it, like I said, as thin as 10 to mm. Right, compared to normal, you use about 50 to 75. Yeah. But only the cost, all right, because 1 meter cube of concrete might cost you like how much? Say 300 ringgit, all right, or high strength concrete maybe a little bit more. But for UHPC, it might cost you a meter cube like 8,000 ringgit, something like that. So that's the thing about using UHPC. Okay.
Okay, thank you very much, Dr. Zack Lim,
Right.
for your answer. Okay. I hope that answer your question, Mr. Muhammad Jamil. So now I think Mr. Alexia has solved the problem of sharing the slide. So now we'd like to pass the mic over to Mr. Rosli Idris for his presentation on the low viscosity for high performance concrete.
All right.
Okay, Mr. Rosley.
Okay. Yeah.
Hello?
Yes, we can. Yes, we can hear you, Mr. Rosley. Please proceed.
Okay. Good afternoon. Yeah, I'd like to have good answer for point. Okay, I think very interesting topic today. So myself, I cover extreme self-compacting concrete. So we're talking about self-compacting, all this thinking about all this thing with the high performance concrete. Yeah. Next, okay. When people talk about self-compacting concrete, I think more and more designer they're talking about solar and larger and more complex structure. And they're also talking about over here, some people talking about 100 over here, and probably have to use more and more XDF. And people always talking about green, or carbon footprint. And there's a lot of challenges when we're talking about effectively, I think the structure becomes more device that people talking about economics, and people always talking about sea level. And now we have in Malaysia, we rely a lot on foreign levels, especially because of chemicals. So I think where these master builders start coming out with the solution to improve productivity, maybe not only in Malaysia but also all over the world, that to reduce labor factors, to match the production demand towards this century. Next, Alex. I think maybe of this problem with the concrete, now the normal concrete is now foreign workers or foreign labor. They have a poor convention. So I think all these try to have to come up with the concrete without any external convention. You see when we have a lot of labor on site, a lot of convention, computers, sometimes instead of completely fabric, not convention or over vibration. So talking about existing, all about site compacting concrete, just concentrating concrete. I think you go through all these Google first, to separate about site compacting and all site consolidation, and also we moderate viscosity. So we're talking about this viscosity, not a high cycle of concrete, always a very high viscosity of concrete. And the other one is like compacting concrete that does not require vibration at all. Compacting and compaction, which is able to grow under its own weight. Just to achieve good compaction, the condenser responsible. Okay, next, Alex. So we talk about these are three main criteria for HCC capacity. One is concrete has to be able to go form of isolated effect without any vibration, without external or internal vibration. Masking ability have to go through all the opposite without communication, both without communication or without any feeling or any aggregate working. And the third one is stability. The ability of the stability to remain homogeneous during and after. So that also has to rely on the one we call it as the data type. Of the action. Next. So these are methods for which you can do all these standards for the HCC. Next. Okay, this video will show you two different types of concrete. One is the stack of XP, the other one is stack of
Again.
On the right hand side, the normal conflict, you can see a lot of people, I think people have to do the complexing, and the other one on the left hand side, the type of complexing, one person completing in 5 minutes, and on the right hand side, the one that normal conflict has to the double their time and workers remaining the application. So it's quite rapidly of self-complexing, the reduced manpower, faster completion, and also better finishing. Next level. So this is all challenging breaking especially pumping. So the system of concrete, the texture, and the construction side. Even though the very actually the contractor or the pump contractor, a subcontractor will have all the benefits. For the pumping for higher or the for the bigger plate, pumping will really play an important role. And on the plating and much more faster. That's where technology don't control all this workability in place, either for low staff or high staff with high education. There's a lot of segregation happen where the homogeneity, the concrete, in the structure on the right hand side, there's a lot of high form and also segregation happen that make the concrete not durable as per spec or as per original requirement by the concrete for the by the consultant. And it's more concrete to repair on. So this is where we have a latest innovation, estimation, from Alex and for the carbohydrate that last 10 years we don't see. Now the next one called quality escalation. This technology mostly on the concrete and here to make it easier to produce, to pump, to place, and reduce vibration and for better thermal efficiency. And in the end, improve efficiency and we have better economical aspect. Next. So I think the benefit of what we want to do for concrete for no concrete clear quite clear. Normally for this self-compacting concrete we have a very, very content. Yeah. So with this no viscosity additive, it makes reduce your fixing time for it. Second one is to improve the function. That's for the pump contractors. Improve placing, improve the finishing, and at the end, reduce environmental impact. Yeah. So all and especially when your design is having a lot of STM, either with the ES or physical steel or fly ash, especially the concrete here. The in 8 years, it helps to sell the concrete. Right? So this is a bit more about the yeah, and this one is the elect, yeah, because of the company. Actually, for to use viscosity, only people just put water, put water, but when you put water, you increase your density and also get the strength. Yeah. So actually, that's elect. or when you have a water, right? When you have a lot of water, also increase your shrinkage, yeah. So from here you see that the water itself gets improved, by PCA improve the stress, but not improve the viscosity. But we do technically more like save the water by having a save from yeah, yeah. Next, so talking about just now mentioned by Alex, all the higher water reduction, higher strength, high flow concrete, they call us, but the disadvantage more the compatibility, especially when you have a higher SPM, higher CSA, higher micronutrient, the rheology or the viscosity become more increased a lot. Yeah, so this is the PAE, water flow, for this type of concrete application. Right? So I think the PAE is combination of two types of concrete. One is the Vaseline, the other one is just now mentioned that Vaseline, the normal one is the limitation in terms of water reduction, but NPC, so it's having a higher water reduction, very high, and the new polymer PAE where they have a both less viscosity, higher water reduction, that is suitable for step of concrete, high strength concrete. Okay? I think it's where the benefit for the baking plant. Normally the challenges is you have longer baking time, yeah, but with the PAE, you have simplification, more homogeneous. It is mainly through productivity by 20%, material wear and tear, also the negative water. Next challenge. So we can skip this one. Yeah, this one to show you, okay, so this just to show you how the yes, the complicating. Normally it's a bit more tricky for normal concrete. And for the easy one, we go to both sides. So adding water, but not adding water, just adding yeah. So much more nearer like adding water, yeah. So this is a standard way of converting concrete sea flow, yeah. CCC or the CCC. Like this is like
A bit lagging a bit.
on the hill. Maybe I think for the conclusion, that product has got in the market for the last 3-4 years. It was a structured, yeah, called Nature Tower, and coming to 90% of completion, about 108 floor, almost the highest PKM of the Malaysia, concrete product at the structure 8 years, yeah, just for your information. So I think typically in Sarawak or Sabah, any material that related to the low viscosity stress convective concrete, high strength concrete, we have a product called, yeah, that's all for much. Thank you very much.
Okay, thank you very much, Mr. Rosley, for presenting us interesting topic on self-consolidating concrete and also self-compacting concrete. So hopefully the audience can benefit from his talk on high self-compacting concrete, which is a type of high performance concrete. Yeah. So is there any question from the floor, Dr. Ahmad?
So far, no.
No question, yeah?
Yeah.
Okay. If there is no question, then I have a question to ask Mr. Rosley. Yeah. So my question is that if you change the viscosity of the concrete, how do we make sure that the bleeding won't happen in the concrete itself?
This validation completely is all about expertise. No? I think everyone's aware that XIA is very, very important, especially for self-competitive concrete. We are talking about the flow of 50, 400 grams, or 700, or 700 grams. The XIA should be more than 55%. Yeah? And it's very, very crucial to make sure that you have a very good FM of the set. The set should be around 2 point, right? So that's 2.8, cannot be more than 2.2, yeah? That's most important. Those are for my guess.
Okay, thank you very much for your answer, Mr. Rosley. And since there is no more question from the floor, I think Mr. Ahmad, can you make me the presenter so that I can share a video? So CMS has made us a video that we can watch and see what is on what is CMS is able to do on this high performance concrete. Okay, that's a video presentation by the CMS group on the high performance concrete that they have to do. In fact, it's already available. Okay, so in fact, the high performance concrete is already available in the market locally. So that's why CMS would like to showcase to everyone that what the high performance concrete that they are able to do. Okay. So from this special CMS special track on latest development in concrete materials, we have listened to Dr. Zach Lim on the best practices for concrete pavement using fixed form. We have also listened from Mr. Yo Si Hong on marine concrete, the requirement and test, and decorative concrete fretworks, what engineers and architects need to know, given by Mr. Eric Song. And then we have role and trend of chemical mixture given by Mr. Alexia, as well as how self-compacting concrete can benefit our Sarawak concrete industry by Mr. Rosli Idris. So now we will start our discussion forum. So I think the host will now upgrade everybody to be a panelist so that everybody can talk, right? So if you have any questions or any issues that you have faced in your work or in your design, you may ask all the experts that we have here today on topics of anything on concrete. No? I think most of the questions all these panelists will be able to answer to you, right? Okay, so can we kickstart the first issue of discussion here? Mr. Yo, do you have anything to share?
Okay. For your info, I tested around, I can say, Sabah, Sarawak, Malaysia, most of the cement. Cement is one of the quite good info. So don't worry, when you use the cement, is tested, they can do more than 100 MPa. The performing with mixture is quite good to test mixture here because they put a lot of additive. Good put admixture that is compatible to the demand. That is what I want to mention. This is what we found out. Our raw material in Sarawak, actually including the granite, is very, very hard, including your limestone is very, very good quality. So you have the flexibility to either use granite or limestone. That is what I want to mention around.
Okay, the issue in Sarawak here is that JKR in their very old spec, they actually specify no limestone to be used in the construction. So what is your view on this?
If you want to know more about the JK aspect, actually under JK aspect, the specification work, building work for building work, and also the road works. The road work should be, I think, 2008 version. The building work should be the latest 2014 version. Inside there's a clause mentioned that limestone can be used. Limestone can be used for construction. They already include the clause in the latest spec, but you can't use it for the 1988 spec for your info. For your info, you cannot use the 1988 roadworks, JKR roadworks. The spec is already too outdated for your info. The 2014 is updated a bit, but still not up to the latest standard, because last year, even the slump test, they already changed to 2019 series. The actual slump test already upgraded. So the EN 206 and also the we about European BS at 500 also updated to 2016. Even Malaysia is updated to 2017 only. So for international project, I will still adopt the European standard from UK.
Yeah, I think that's the problem with updating ourselves with the specifications.
Yeah.
So still a lot of practitioners, they still refer to very old specification without knowing that there's already new specification out there that is available for use.
Yes.
So
they commonly they thought that the new Euro code will be less conservative for safety factor example. How experience the new Euro code, because they use the new material and also the new design, your construction cost actually can cut 3-5%. That's what we understand. If you are using the latest Eurocode example in the BS Eurocode 2 Part 3, the water retaining structure. Previously, it's known as BS at 007, water retaining structure, the design. Actually, the latest water retaining structure under Eurocode is more stringent. The allowable crack width is 0.125, if I'm not mistaken. So they already make it more stringent rather than compare 0.2 in the previous BS at 007. That one is for your information, for everyone's information. So Singapore adopted Eurocode. So that's how they save the construction cost. Okay.
And in Malaysia, in fact, it's mandatory to use Eurocode 2 for building design since 2008. But I'm fortunate to say that in Sarawak, we are still using the BS 8110 most of the time.
Don't worry,
So
when you bring the international standard to Sarawak, don't worry.
So it's time for all the new engineers to bring all the new thoughts to their boss and tell them that, hey, we have a new standards of practice already. So please let us use the new standards rather than just relying on the old standards, which is sometimes quite conservative.
Yes, agree.
It actually limits us from venturing into exploring the use of new materials.
Yes.
We are still stuck with the old course of practice. Okay, anything to add from the floor? Dr. Adeline Ng from Swinburne, do you have anything to share with us? I see your name there.
Thanks, Prof. Ng. No, a very clear
Welcome.
presentation. Thank you, thank
Okay.
you.
Welcome to our
Very
session.
interesting presentations. Yeah,
Yeah.
very interesting presentations. Thank you.
Okay. All right. Thank you very much. Any,
Mr.
any
CEO.
Yes.
Yeah, I just want to know that by your presentation just now is you said that limestone as aggregate is giving better strength compared to the granite. Just can you share with us briefly on what reason limestone is better than granite?
Okay, if you want to talk about how we select aggregate, this is we talk about the Euro code EN 12620. Okay, they choose the aggregate based on the hardness. That is the commonly known by the OCOD is. So we found throughout the research in Kuching and Sarawak, we found out the aggregate hardness, let's say the SCV, the aggregate crushing value. That means it's a test to test the hardness. Your granite actually and your limestone, they have similar hardness, I can say. Assume the SCV of granite is 20, your limestone is almost 20, 21, 22, example, which is slightly less than that. Then in terms of hardness, they are quite similar. So it doesn't actually affect the slight variation doesn't actually affect the strength. So when we tried in Kuching, in the CMS factory, precast product, we actually tried it and we found out the strength is quite similar. And one day actually we can achieve more than 30 MPa. We stop around 3 days, we can even go to 50 under special design. So the cement content, we are not using very high cement content, roughly like normal grade 50 cement content, I can just say like. But throughout the testing, we found out because the hardness is almost similar, it doesn't actually affect your lateral strength. And one good thing of limestone aggregate is the limestone aggregate actually have lower coefficient of thermal conductivity, which is very important parameter for repair material and also concrete pavement example. Because under under the weather, hot weather, your concrete will expand less if under the heating of the sun. Compared to granite, your coefficient of thermal expansion is higher. So let's say under 10 degree of sunlight increment, your concrete expand more compared to limestone aggregate concrete. And that one is very important. When your concrete expand too much, actually your concrete crack. So by using limestone aggregate within your concrete, actually your concrete is more volumetric stable. That is very important. For your info, I have a project in it's the near North Korea there, Dalian. Okay, the whole building is an electronic factory. I'm using limestone aggregate because the nearest granite you need about 1,000 kilometers to import in. So we have no choice to use limestone aggregate. We have no issue for that. We even get the grade 50 strength, actually 60 more than that. So the whole building construction cost, the whole building is 1 billion US dollar, 1B US dollar. So it's not an issue for making a very sensitive structure, even a sensitive structure. So limestone can be used. However, all kind of aggregate before you use, please test the reactivity according to the code. Because throughout my career, I found out there are certain aggregate supplier in Malaysia. They especially I don't want to say where is it. The aggregate is quite reactive. Then you have alkali aggregate reaction that is very dangerous. It's called concrete cancer. So that is what I want to highlight only. All kinds of aggregate. Yes. And hopefully I answer you.
Yo,
Thank you very much.
sorry. So, Yo, I'd like to interrupt. So just ask you, what is the water absorption between the granite and the limestone?
Okay.
Do you know about that?
We talk about in Kuching. Mr. Lim, we talk about Kuching first. So Kuching one, I think the granite is almost 1%, around 0.5 to 1%. Limestone also quite similar. But Kuching is different because the O formation. The geological formation, actually the limestone is very old. The edge of the limestone. That's why they have very good quality. The hardness is there.
Okay, thank you. That means we cannot use that from Batu Cave anymore.
You can use, but let's say if your absorption is very high, I think even JKR is putting a very high absorption rate, should be up to 8%, but that one we consider even more than 1%, roughly around 1% the most. Even the one in Batu Cave. But the good thing is, Mr. Lim, for us, like we repair road or pavement, limestone aggregate actually perform better than our granite, the siliceous aggregate.
Okay, thank you.
Okay, thank you.
Okay, is there anything more to add from the participants regarding the use of limestone aggregate? I think this is a very interesting topic. I think a lot of time we are very scared of using limestone aggregate in the projects. But now with the new court requirements, you are able to use limestone. So I think it's a good start.
Yeah, just to add to that, when I started in construction in the early 80s, a lot of houses probably they are only double story, and they use a lot of limestone for the concrete. Nobody bothers at that time, right? It's not meant to be. And then even the hardcore, we call it, where it's the round pebbles, right? Even they use that for concreting, and the building still stands today. So I think it's not a big issue. Yeah. Okay,
I think we can go and do a forensic engineering on those old structures that is built using limestone and see whether it performs better than those built by granite. Okay, Dr. Zach-Lim, you can continue.
No, okay. The other thing, just now we are talking a lot on high early strength concrete. Okay, so I think generally most high early strength concrete in 24 hours you probably achieve like 20 megapascal, right? So I don't know anybody has any formulation that can beat that, right? And from my experience, I've actually brought in some admixtures from USA, and I think in 8 hours we can achieve close to 35 MPa. It's only thing the cost, right? The cost only. Yeah. Anybody has got anything better than this? I mean, 8 hours, 35 MPa.
I think some of our researchers have already achieved around 80 MPa in 24 hours, but then they have not reported the 8 hours strength. So, but 24 hours they can achieve 80.
Okay.
With reactive, yes. They grind the silica film down to nano size. So
Yes,
it's super reactive.
Okay, last time, ACI Malaysia, we had every year we have a concrete cube test competition, and one of the university they use rice hush ash, and 24 hours they achieve more than 100 MPa. I still remember that. Yeah. So it's very interesting. That's why. Yeah.
Yeah, I think for that they They have also ground the particle down to
Right,
normal
right.
size probably.
Yeah,
Yeah.
no, I think they burn micro oven. They have to burn it. I heard they burn it. Yeah, micro oven.
Okay. They burn it to a smaller particle size, probably.
Right. Yeah,
The ash is very, very fine.
Right. Yes. Okay, that's all I got to share.
Prof, do you want to see the code, the JK aspect? I have the latest one. I can show a while if I able to share the screen for a short while.
Okay, no problem. Dr. Ahmad, please make Mr. Yo the presenter.
Okay. Try to share my screen. Okay. This is the latest standard specification for building works. Okay. I just do search first, limestone. Okay. So under section D, concrete works, this is the document number. This is the latest one. The material here, cement, okay, everything, transport, storage, aggregate. Aggregate shall be naturally occurring sand, granite or limestone, crushed or uncrushed. Okay, so in this code, they mention MSEN 12620. So anything they can refer this MSEN 12620. So limestone actually can be used for your information and is clearly stated within JKR standard specification for building works 2014. The number is called JKR 2008-0183-14. This document actually stated limestone can be used. So when next time engineers in Kuching will encounter this, actually you can refer this code for JKR project. Any other question regarding JKR spec? I also can talk about it.
Okay, thank you, Mr. Yo, for sharing the JKR specs. I think we have a few participants here who is from JKR Sarawak. Do you have anything to add on to this? Are you using this spec now? Are all your monitoring of projects and specification that you have written all based on these new documents?
In 2018, actually JKR asked all the experts. That time I'm representing IEM. We have a meeting in the JKR HQ. Actually, we have changed all these things, updated to the latest. Now this one 2014 is still I consider obsoleted already because the Eurocode keep on evolving. So we even change all these things to update it to the latest Eurocode. But unfortunately, that JK aspect haven't come out yet. In 2018, we already sit down together with the JKR, the top management, with the Cawangan Pakar. We try to change all these things to the latest spec. Because in this old standard, they even limit the amount of time you must finish your concrete thing. However, today with the latest emission technology, just now like what CMS has shown, actually they even can prolong or so-called slump retention. They can prolong the slump up to 6 to 8 hours. That is what we can do today. So it's depending on how you design the mix. And please in mind, just now okay, this one is always a question. Okay, so as we see down here in the JCAN aspect, the okay, The concrete mix, classification of concrete mix. The concrete mix shall be design concrete. Just the consultant spec down the requirement. The consultant spec down the requirement. Then the ready mix or the producer will follow the requirement. Okay, this is the meaning. So JKR project, please use design mix. Don't use the 124 mix, please. Comply to MS 523. But 523 part 1 already obsoleted. Now it's 523 part 2 and part 3. They change it. 523 part 1 is replaced by MSEN 206, if I'm not mistaken. So for prescribed concrete, the 1.4, for normal concreting work, volume batching is permitted, provided, okay? For small volume of work, keep in mind, for the prescribed concrete 124. Okay, just to let everyone know about it. This is very, very important because sometimes we face difficulty, they want slump 75 or 50 at the site. Those are the old prescribed mix. But in actual construction, we must use design mix, comply to MS 523. Okay, I hope everyone is clear now. It's very, very important. You can put your slump or floor 125 plus minus 25, okay, or you can high flow concrete.
Okay, thank you very much, Mr. Yeo, for sharing with us the latest JKR specs. Huh?
Okay, thank you.
Probably you can highlight to the audience, because I think in practice they are still not very aware of how is the acceptance criteria for conformity of concrete. Okay, please share with us in JKR spec.
The conformity, you mean the standard deviation?
Yes, the standard deviation and all that. I think a lot of...
Okay, that one that there Prof. Tam have mentioned. That one will be a very I can't explain in very short time like this.
I understand.
Sorry that this one I have to prepare a lot of document. There are certain criteria. The standard deviation should not be more than certain value. Then how many? There are certain parameter you need to consider. Then the plant, every 35 bench of concrete, what you should see, all the statistic you need to consider. Okay, the very simple thing. Very, very simple. We don't talk about the statistic first. When you go to the production plant, example, you go to the ready mix plant, you request all the previous statistic and previous concrete strength. Then ask them to plot the average concrete strength for 1 month. Let's say your grade 50. For this 1 month, normally if I go and select the plant, for this 1 month, you see how stable is the grade 50. Every time more than 50 or sometimes it lower than 50. That is how the simpler way to choose. We don't see the standard first. We just follow use the compressive strength to plot every day the grade 50, roughly how much is the average strength. You can see the line, you plot for plot. Last few weeks, Prof. Tam actually showed that Singapore, they are doing that. They look at the chart. So how stable is your grade 50? Is it sometimes drop less than 50 or every time is 55 or 60 MPa? That's what we are looking at. You must see the daily production strength. That is more real world concrete strength rather than you go and do trial mix. I just want to say like that. Because trial mix, every time they buy good aggregate, good sand, the result is extremely good. The simplest way to identify is ask them to provide over 1 month of history. I can say the history of your concrete strength. Then from there, you analyze whether the plant is performing or not.
Yeah, thank you very much for sharing, Mr. Yo. In
Okay.
fact, this is the acceptance criteria, I think, written in this JKR spec also,
Yeah,
where
but
you have the initial batch, either you have the initial test, initial batch, or you have the continuous production. No?
yes, 35
So,
set. Okay.
Yeah,
How many
if you have
sample?
if you have 35 sets of data, then you can classify it as a continuous production.
Yes.
And then you have to look at the standard deviation of all these 35 set of data.
True.
And the latest 15 data, whether they falls into certain range of standard deviation or that is quite complicated actually.
Yeah,
but
we
in fact,
cut it simple. Just take the history for 1 month, then you know.
Yeah. So this is why we want to make things easy for the practitioners.
Yes.
If you refer to the spec, you don't know what it's saying sometimes.
Yes. Because it will take a lot of, even I need to prepare extra slide, but even like in China, I have 12 plants. I check the capacity first. I give them a standard mix design. So they will run the test. They cast many cubes. Then out of 12, actually 3 only can pass, because from my mix design, I know if let's say 400 kg cement, at least I get 50 MPa. But out of these 12 plants, only 3 to 4 plants actually can achieve that. That means the other 7 to 8 plants, actually, they are not performing. For info, that is how I test the actual plant. I give them a mixed design, which I know the data, do the casting, they cannot achieve the strength, so I know the plant don't have sufficient quality control. That is what I did. But to make it simple, you just take the strength history, verified by the testing lab or verified by the consultant with witness, must be witness result.
Okay, thanks very much for the advice, Mr. Yo. I think that will make the engineer's life easier rather than calculating all the standard deviations and all that. I think you get lost in the halfway when you do the calculation.
Yes.
Okay.
Too much thing to calculate. If you follow the 206, too many parameter you need to look in.
Yeah, that's right. And it's so complicated for the engineers already, more so for the cloud of works or on site. Yeah.
I think because I think I have cooperate with our friend CMS. They a lot of data. If you want to buy concrete, you can ask for that data as a selection. Last time we know we have a lot of casting. You have the data there.
Okay, so for all the practice engineers, I think this is a very important aspect in the new British code, the Euro code.
Yes.
This is the BSEN 206 on acceptance criteria of concrete. So anything to add from the discussion topic on this JKR specs? Any comments from the floor?
Oh, I have one question from the audience.
Yes.
Okay.
This is for Mr. Yo again. Seems like they like to ask you a question.
Okay.
Can limestone aggregate be used in square tile? Because according to JKR 2014 building spec clauses 2.2.2 for work below ground level, only crushed granite should be used by Mr. Azman Haimi.
Okay, thank you, Asman. Okay, so technically, if you ask me, yes, they can be used because the latest Eurocode actually allow. They don't tell you whether you or underground. Example is the China project, the one in Dalian. We are casting limestone aggregate within the concrete. We have no issue with that, for your info. What is the okay, I have deal with even JKR Brunei before. You know why they don't allow, generally, why they don't allow limestone? I asked before, the region are not only Sarawak, Sabah, or Malaysia. They told me because previously, they have experience when using limestone, the building collapse, or they have experienced the limestone actually can underperform, cannot reach high strength. Okay. Experience by the consultant. I mean, the one who is writing the JKR spec. That is the reason. That's the reason. They have aggregate cannot achieve high strength. But this is untrue now, today, because technology has evolved. Time we even cannot get the normal natural sand. We even need to use the manufactured sand in certain project. So with the old spec, yes, you don't even, they call the manufactured aggregate as quarry dust or west rock powder. But today, with the technology, actually you can use the so-called rock powder in our concrete. Same to this. Previously, limestone aggregate might not perform, but today, with technology, limestone aggregate can even achieve grade 50, 60 easily. That is my opinion. When they this standard JKR, this is considered 20. Right, I think it's around 2012 or 2013. So this I can say is all. In general, we say from international point of view, this is outdated spec. Not because cannot use, because the spec haven't up to date. I just want to highlight this. Mr.
Okay,
Asman,
thanks,
hopefully I answer it.
Okay, Mr. Azman, does that answer your question?
Yeah, thank you. Thank you so much, Mr. Yo.
Thank you.
Okay, is there any question or issues that you would like to discuss from the floor? Okay, I have from what I've read, there is a type of concrete. I think this is more relevant to Mr. Eric Sung on decorative concrete. So they actually use fiber optics in concrete mix to make the concrete transparent. So I don't know whether you have experience on this type of concrete or not.
No, I have actually not come across the fiber optics technology actually.
Oh, okay. It's quite. In fact, it's quite interesting. They arrange the fiber optics to pass through the concrete, and then the concrete can be illuminated, and then you can see through the concrete. Yeah, yeah.
Right. It's very interesting. But
so that's a very interesting area.
Right. Something that can
architectural
probably
features.
onto that as well.
It looks quite beautiful.
Yeah. Okay. I think just to add to it, I still think while casting the concrete, they actually embedded all these fiber optic in there, and after that they still have to cut it, so that all the ends of the optic fiber is exposed. So that's where lights can travel through. I think that's how they do it.
Yes, they have to arrange the.
It's not
that's correct,
difficult. Yeah. Right. Yeah.
Yeah. And then another aspect on concrete that I would like to discuss about is 3D printing. In fact, this sleeve forming is actually the father of 3D printing, actually. So where Dr. Zach Lim has already shown us sleeve forming in doing the concrete pavement. That is actually the father of 3D printing. So nowadays they've already made use of 3D printing to build bridges, to build houses. No? So what are your opinions on this 3D printing technology on concrete? Any input from the panelists here? Has anyone come across any project that is using 3D printing in using
I mean,
concrete?
definitely, I haven't seen it in Malaysia yet, like I say, China is quite advanced on this. Of course, Europe, but I think China is catching up very fast. All right. You can see from the videos, the YouTube, I think they have done tremendous using 3D. I've seen a lot of videos on that.
Yeah, that's one technology that we should look at. It may be the trend of the future.
Right.
Agree. The idea is when you extrude out, you need to control the setting time. Actually, you discussed this before. When you extrude out the time, sometimes you cannot use OPC alone. You need to use. So when you extrude out that time, when the next round, when it goes back, the bottom one must at least set already.
Yeah, that's the challenge.
Yes, your setting time. So one of it is additive. Hopefully our friend, actually I believe NBCC, they have certain additive can be used. If I'm not mistaken, Alex, correct?
Yeah, actually for this 3D printing technologies, hello?
Yes.
Yeah, I think in our
Yes, we can hear
UAE,
you.
in our UAE counterpart, they actually invest quite heavily on this 3D printing. But unfortunately, in Malaysia, we still have not started yet. Yeah, but I think in country like what we know is the UAE, they have actually invested very heavily on this 3D printing. And then they also mentioned that this will be all the trend that the construction market will actually pick up these technologies. Yeah.
Yeah, that's why I think Malaysia will have to start picking up.
Yeah.
If not,
Yes,
we'll be
yes.
left behind. Yeah.
Yes. Because now the first thing is low carbon footprint. Prof, just now you mentioned about you want to replace high amount of SEM, right, in the concrete, but with certain early strength, right? For your information, the COCO project I mentioned earlier, the high early strength mass concreting and mass concrete, the binder is 450 below, actually far more less than that. We get quite high flow concrete. I can say diameter is around 500. Okay, high flow is not SEC. Okay, high flow concrete. More than 50% is the SCM. Then 12 hours, we get about 15. 12 hours, we get 15. Okay, because they need to demo. It's very big, 1.4 meter, 1.4 meter times 6 or 8 meter, the precast beam. So we can achieve certain early strength, but the admixture actually is all tailor-made. The material is special selected, but the client is very happy. Actually, is a European. The consultant that time is the Arup Singapore. So we actually use almost 50% of cement replacement, high early strength. At 28 days, we get 85, around 85. So
What type of SCM do you use?
down there, we have plenty of GGBS, but
Okay.
even GGBS, you have 3 grade. I understand that in future Sarawak, we also have GGBS. So I think you can use a lot of this material in future. We tried, I think fly ash 30% is not an issue for us also. Our experience get very high early strength for info, but everything
Yeah,
is tailored.
If you can get a 30% replacement of fly ash with early strength, I think that is a great achievement.
Yeah. For info, because that kind of project, the client, my client is a precaster, but the end client actually social media, one of the largest social media company in the world. So they must have plan of cement replacement inside your concrete, because those are American. They want your concrete to be low carbon footprint. The concrete technology, we're not only talking about low carbon footprint, we are also talking about performance. That is what we want to bring up today. So don't worry about the early strength. We still can solve it, but you need a tailor-made emission and select the right material.
Okay, thank you very much, Mr. Yeo, for your input. I think we are coming to the end of the session already. It's almost 5 o'clock. So probably I will wrap up the session by extending our thanks to all the panelists today, Dr. Zach Lim, Mr. Yeo Shi Hong, Mr. Eric Sung, Mr. Alex Yap, and Mr. Rosli Idris for being with us for almost the whole day. Thank you very much for your time, sharing your time with us and sharing your knowledge with us. Okay, so I think I have learned a lot from you all, and I hope it's the same for all the other participants. Okay, so and also I would like to extend my thanks to CMS group, Jaya Mata Sarawak, for sponsoring this special track on latest development in concrete material. So I hope to see everybody probably in the next engineering conference, probably next year or the year after next. Okay, thank you very much, everybody, for attending this session. And goodbye and have a great day ahead. Okay, thank you very much. So with that, we will conclude this special session. Yeah. Okay, thank you very much.
Thank you.
Okay, thanks.
Thank you, everyone.
Thank you. Okay, bye bye, everyone.